Have you ever stood beneath a quiet night sky and wondered, not just how big the universe is, but whether it has an edge at all, a final shoreline where space itself seems to hesitate and say no further? You see, because that simple question has followed humanity for as long as we have been able to look up and feel small beneath the stars. Well, we grow up drawing borders on maps, edges on paper, beginnings and endings that feel reassuring. And perhaps we quietly assume the universe must obey the same logic. But what if it does not? What if the cosmos is far stranger, more subtle and more poetic than a wall at the end of space? And that is the thing. When scientists speak of the edge of the universe, they are not pointing to a place you could ever reach, not even in imagination. They are speaking of light, of time, of the simple yet unsettling fact that the universe reveals itself to us only at the speed it allows information to travel. You look out into the darkness and every galaxy becomes a memory, every faint glow a message sent long before there were eyes to see it. Perhaps the edge of the universe is not a destination but a horizon, like the line where sea meets sky, always visible yet forever out of reach. And when you follow that thought far enough, the familiar rules of physics begin to soften. Space stretches, time bends. Intuition, shaped by life on a small planet, quietly steps aside. I suppose what draws us here is not the promise of answers, but the invitation to wonder. Because at the edge of everything we know, the universe seems to whisper a question back to us. How much of reality lies forever beyond our view, and what does that say about our place within it? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. When we speak of the edge of the universe, you see, we often imagine something solid, something final, as though there were a last star and then nothing beyond it, a cosmic cliff where existence simply stops. But that picture, comforting though it may be, is not what modern cosmology describes at all. The edge that astronomers talk about is not the boundary of everything that exists. It is not the rim of creation. It is something far more intimate and perhaps far more unsettling. It is the edge of what we can see. The observable universe is not a physical container, but a consequence of time, light, and the finite age of the cosmos. And that is the thing. The universe may be vastly larger than the portion that reveals itself to us, or it may even be infinite, stretching on without end, indifferent to our attempts to map it. Imagine standing in a dark field on a foggy night. Your vision fades, not because the world ends a few meters away, but because the light reflected from distant objects can no longer reach your eyes. In much the same way, the observable universe is defined by a horizon, not in space, but in time. We see only as far as light has been able to travel since the universe became transparent. Well, that means every direction you look, whether you turn your gaze north or south, toward Orion or Andromeda, you encounter a limit, not a wall, not a barrier, but a moment in the distant past beyond which no signal has yet arrived. Each direction has its own edge, its own horizon of visibility, shaped by the same cosmic history but experienced from the unique vantage point of Earth. This is where our everyday intuition begins to falter. We are used to thinking of edges as places you could, at least in principle, walk toward. But the edge of the observable universe is not something you could ever reach, no matter how long you traveled or how fast your spacecraft might go. As you move through space, time continues to pass, and light from ever more distant regions has more opportunity to reach you. The horizon shifts. The edge recedes. It is like chasing the horizon at sea. You can sail for days, weeks, perhaps a lifetime, and yet the horizon remains stubbornly ahead of you, always the same distance away. And, that realization carries a quiet, philosophical weight. The limits of our knowledge are not fixed in place, but woven into the fabric of space-time itself. What defines this cosmic horizon is not distance alone, but duration. The universe has a finite age, and light travels at a finite speed. These two simple facts conspire to create a boundary of perception. When we look at a galaxy billions of light years away, we are not seeing it as it is now. We are seeing it as it was when the light began its journey, long before our planet existed, long before the Earth had oceans or continents, long before life stirred in any recognizable form. To look far away is to look back in time, and the farther we look, the younger the universe appears. Near the edge of what we can observe, we glimpse an era when galaxies were only beginning to assemble, when matter had not yet settled into the grand structures we see nearby. In that sense, the edge of the observable universe is not merely distant, it is ancient. Perhaps this is why each direction in space carries its own edge. Because every line of sight is also a line into the past, the universe does not offer us a single frontier, but countless overlapping ones, each defined by the same cosmic clock ticking away since the beginning. You could say that the edge of the universe surrounds us completely, not as a shell of matter, but as a sphere of time. Wherever we stand, we are at the center of our own observable cosmos, and that sounds at first dangerously close to an old and comforting idea, that we occupy a privileged position. But you see, this is not because we are special. It is because every observer, anywhere in the universe, would see much the same thing. Each would have their own observable universe, centered on themselves, bounded by the same laws of physics. As time passes, this edge does not remain fixed. The universe is aging. Light from more distant regions has had more time to reach us. In that sense, the observable universe grows. The horizon expands. Regions that were once hidden gradually come into view. But here, again, intuition can mislead us. Because at the same time, the expansion of space itself is carrying distant galaxies away from us. Some are receding so quickly that light emitted today will never reach us at all. So while the observable universe grows in one sense, it also loses contact with parts of itself in another. There are galaxies we can see now whose future light is already beyond our reach. They are slipping away, not because they are moving through space too fast, but because space itself is stretching between us. This means that the edge of the observable universe is dynamic, a living boundary shaped by the competing influences of cosmic expansion and the relentless march of time. A galaxy that lies within our horizon today may eventually cross it, fading from view as its light becomes ever more stretched, ever more red, until it dissolves into the background glow. And perhaps, I suppose, there is something quietly melancholic about that. The universe does not only reveal itself, it also withdraws. There are parts of reality that we can observe for a brief cosmic moment, only to lose them forever as the universe continues its expansion. When cosmologists speak of the edge moving, they are not suggesting that the universe has a center from which the edge marches outward. Rather, the change is woven into the way space-time evolves. The boundary is defined by what is causally connected to us, by what can influence us and be influenced in return. This causal structure is what gives meaning to the idea of an observable universe. Beyond it may lie countless galaxies, perhaps entire realms of space and time, but they are for now and perhaps forever disconnected from our story. They exist, if they exist at all, in a region of the cosmos that cannot exchange information with us. And that brings us to a subtle but profound point. The edge of the observable universe is not an edge of existence. It is an edge of knowledge. It marks the limit of what we can, even in principle, observe. And yet, science dares to speak about what lies beyond, not through direct observation, but through theory, mathematics, and the quiet confidence that the laws of physics do not abruptly change just beyond our sight. We infer. We extrapolate. We imagine a universe that continues beyond our horizon, much as it behaves within it. But we must do so with humility, always aware that inference is not the same as observation. The idea that the observable universe is bounded by time rather than space invites a different way of thinking about our place in the cosmos. We are not enclosed in a cosmic bubble with a hard shell. We are immersed in a vast, evolving space-time, able to glimpse only a finite portion of it. Our cosmic map is incomplete by necessity. There will always be regions we cannot see, events we cannot witness, histories that remain untold. And perhaps that is not a failure of science, but a feature of reality itself. The universe does not present itself all at once. It reveals itself slowly, selectively, through the narrow window that light and time allow. As we contemplate this, it becomes clear that the edge of the observable universe is not something remote and abstract. It is intimately tied to the act of observation itself. Every telescope, every detector, every measurement is constrained by this horizon. When astronomers push their instruments to greater sensitivity, they are not merely looking farther in space but deeper into time. They are approaching ever more closely the earliest moments from which light can reach us. And at that threshold, the universe begins to look profoundly different. Matter behaves strangely. Structures are simpler, more chaotic. The familiar order of galaxies and clusters gives way to something more primitive. And so, as our understanding of the observable universe deepens, our questions naturally shift. If the edge we see is not the true edge of everything, then what truly defines the universe as a whole? Is it finite or infinite? Does it curve back on itself? Or does it stretch endlessly onward? Are there regions forever beyond our reach? Not just practically, but fundamentally. These questions linger at the boundary of observation, inviting us to follow the light itself, to consider how it shapes everything we know and everything we can never quite touch, drawing us gently toward the role that light plays in carving the very limits of our cosmic vision. And so, standing at that shifting horizon of time we spoke of, it becomes impossible to avoid the true architect of this boundary. Not space itself, not distance, not even the vast expansion of the cosmos, but light. You see, light is the great messenger of the universe, the only reason the cosmos is visible to us at all. Every star, every galaxy, every faint smudge at the limit of our telescopes announces its existence through photons that have crossed unimaginable distances. Without light, the universe would still be there, unfolding and evolving, but it would be forever silent to us, hidden in perfect darkness. Light determines how far we can see, because it determines how far information can travel. There is no shortcut around this. No matter how powerful our instruments become, they cannot gather what has never arrived. And so the observable universe is, at its heart, a map drawn in light. Each photon that reaches Earth carries a story, a fragment of cosmic history. The more distant the source, the longer that story has been traveling, and the older the chapter of the universe it describes. Well, that means our cosmic vision is not limited by curiosity or intelligence, but by a fundamental speed limit written into reality itself. There are vast regions of the universe that exist right now, whose light has never touched our planet. Entire galaxies may be shining brilliantly, forming stars, collapsing into black holes, all without leaving the slightest imprint on our skies. They are real in every physical sense, and yet, for us, they might as well be ghosts. Their photons are still on the road, moving steadily outward, but the universe is so young and so large that those signals simply have not had time to arrive. And perhaps, I suppose, they never will. Space is expanding, stretching the paths that light must cross, and in many cases stretching them faster than light itself can compensate. This idea can feel deeply counterintuitive. We are used to thinking that if something exists, we should be able to see it, given enough effort. But the cosmos does not bend to that expectation. Existence does not guarantee visibility. The universe does not owe us completeness. There are places that are real but permanently inaccessible, not because of technological limitations, but because of the way space-time itself unfolds. And that realization can feel oddly humbling. The universe is not built for observation. Observation is something we do, locally, briefly, within narrow limits. Among all the light that reaches us, there is one signal that stands apart, one that defines the ultimate boundary of what we can see. Long before stars ignited, long before galaxies assembled, the universe was a hot, dense plasma where light could not travel freely. Photons were constantly scattered by charged particles, trapped in a blinding fog. Then, as the universe expanded and cooled, a remarkable transition occurred. Matter became neutral, space became transparent, and light was finally released to travel on its own. That ancient light still fills the universe today, stretched and cooled by billions of years of expansion, now arriving as a faint glow in the microwave part of the spectrum. It is the oldest light we can observe, a kind of afterglow of creation itself. When we detect this background radiation, we are seeing the universe at a moment when it was astonishingly young, smooth, and simple compared to the richly structured cosmos around us now. There are no galaxies in that light, no stars, no planets, just subtle variations in temperature and density, tiny ripples that would eventually grow into everything we see today. And that is the thing. This ancient light marks a limit, not because nothing existed before it, but because nothing earlier can communicate with us. Beyond that moment, the universe is hidden behind an opaque veil. Physics can describe it. Mathematics can explore it, but observation cannot reach it. As light travels across the universe, it does not remain unchanged. Space itself stretches, and, as it does, it stretches the wavelength of the photons passing through it. This is what astronomers call redshift. Light that began its journey as energetic and bright gradually loses energy, its wavelength growing longer, its color shifting toward the red, and eventually beyond what human eyes can perceive at all. The farther the light travels, the more pronounced this effect becomes. Near the edge of the observable universe, light is stretched so severely that it fades into the faintest whispers, barely detectable even by our most sensitive instruments. In this way, the edge of the universe is not marked by darkness, but by dilution. Light does not abruptly stop. It thins. It weakens. It is pulled apart by the expansion of space until it becomes almost indistinguishable from the background. The universe does not end in a wall of blackness, but in a gradual fading, like a sound carried farther and farther away until it blends into silence. And perhaps that is a more fitting image for the cosmos. Not a dramatic boundary, but a gentle vanishing. The farther we look, the redder and weaker the light becomes. Nearby galaxies shine with familiar colors, distant ones glow faintly in deep reds and infrared hues, and at the greatest distances, their light slips entirely out of view, not because the galaxies are gone, but because their photons have been stretched beyond our capacity to detect them. This means that the observable universe is shaped not only by time, but by the limits of light itself. What we can see depends on what wavelengths we can measure, and how well we can separate those faint signals from the cosmic noise. There is something quietly poetic about this. The universe reveals itself to us only through messengers that are altered by the journey. Every photon arrives tired, stretched, bearing the marks of the space it has crossed. We never see the universe as it is now at great distances. We see it as it was, filtered and transformed by time and expansion. Our cosmic view is always, inescapably, a memory. And yet, light is also astonishingly faithful. Despite traveling for billions of years, despite being stretched across an expanding universe, photons still preserve information about their origins. Their energy, their polarization, their distribution across the sky all carry clues about the conditions in which they were born. By studying this ancient light, scientists can reconstruct the history of the universe with remarkable precision. The edge of observation, then, is not merely a limit, but a treasure trove. It is where the universe is simplest, cleanest, closest to its beginnings. Still, there is a profound asymmetry hidden here. For every photon that reaches us, there are countless others that never will. Some regions of space are already receding so rapidly that any light they emit now is doomed to eternal exile, stretched and carried away faster than it can close the distance to Earth. Those regions are slipping beyond our causal reach. They are not just unseen, they are unseeable, and this process continues relentlessly. As the universe expands, more and more of it crosses that invisible line where communication becomes impossible. This means that the role of light is not just to define what we see now, but to shape what we will ever be able to see. The observable universe has a future horizon as well as a past one. There are galaxies we can observe today whose future light will never arrive. We are catching them at a fleeting moment, like ships glimpsed at dusk before they disappear beyond the curve of the sea. And, that realization gives the night sky a kind of urgency. The universe is not only revealing itself, it is also quietly slipping away. Light, then, is both generous and cruel. It brings us knowledge from unimaginable distances, yet it enforces an uncompromising boundary. It allows us to see the universe as a whole, but only up to a point. Beyond that, reality continues in silence. And perhaps, I suppose, that is why light occupies such a central place in our attempts to understand the cosmos. It is not merely illumination. It is connection. It is causality. It is the thread that binds events across space and time. As we follow that thread outward, toward ever greater distances and ever fainter signals, we begin to notice something else. The behavior of light itself reflects the deeper behavior of space. The way photons are stretched, the way horizons form, the way visibility fades, are all consequences of a universe that is not static, but dynamic. Space is not a fixed stage on which light performs. Space is an active participant, expanding, evolving, shaping every journey a photon makes. And so, as we continue outward, guided by light to the very limits of what can be seen, our attention naturally shifts from the messengers to the medium they traverse. Because the ultimate reason light defines a boundary is that space itself is growing, carrying distant regions away from us, reshaping horizons, and ensuring that the edge of the observable universe is not just a matter of sight, but a consequence of cosmic expansion that becomes ever more pronounced the closer we look to that distant, fading rim. And so, as our gaze follows light outward to where it thins and reddens into near invisibility, we begin to notice that the true sculptor of this cosmic horizon is not light alone, but the stage upon which it travels. Space itself is not still. It is not a quiet, empty container waiting patiently for stars and galaxies to move within it. Space is restless. It stretches. It grows. And at the very edge of what we can observe, that stretching becomes the dominant story. You see, when astronomers say the universe is expanding, they do not mean that galaxies are flying through space away from some central point. That picture, though tempting, is misleading. Instead, the distances between galaxies increase because the fabric of space between them is expanding. Every region of the universe participates in this growth, but its effects become most dramatic at great distances. Near us, the expansion is subtle, almost imperceptible. Gravity binds galaxies together into clusters, clusters into superclusters, holding them in place against the gentle pull of cosmic expansion. But farther out, where matter is more thinly spread, expansion wins. As you move closer to the edge of the observable universe, space stretches more rapidly relative to what lies nearby. This does not mean that there is a special location where expansion suddenly accelerates. Rather, the farther away a galaxy is, the more space there is between it and us, and therefore, the more expansion can accumulate. Distance amplifies expansion. A small stretching per unit of space, multiplied across immense cosmic distances, becomes overwhelming. And so, the most distant galaxies appear to recede the fastest, carried away on the swelling tide of space-time itself. This leads us to one of the most startling discoveries of modern cosmology. Some regions of the universe are receding from us faster than the speed of light. At first glance, this seems impossible. We are taught that nothing can move faster than light, that this is the ultimate speed limit of reality. And that is true, but only locally. No object is breaking the cosmic speed limit by racing through space faster than light. Instead, it is space itself that is expanding, increasing the distance between us and those distant regions at a rate that exceeds how quickly light can close the gap. Well, this distinction is subtle, but crucial. Einstein's theory of relativity forbids objects from outrunning light through space, but it places no such restriction on the expansion of space itself. Space is not an object. It is the geometry within which objects exist. When that geometry changes, distances can grow without violating any fundamental law. And that realization forces us to let go of our everyday intuitions. The universe is not constrained by the rules of motion we learn from cars and planes. It plays by deeper rules written into space-time itself. At the edge of the observable universe, this expansion shapes everything we see. Light emitted by distant galaxies struggles against the stretching of space. Each moment it travels, the space beneath it grows, pulling the photon's wavelength longer, draining its energy. In some cases, the expansion is so strong that the light never reaches us at all. It is not that the photon turns around or vanishes. It continues moving forward at the speed of light, faithfully obeying the laws of physics. But the destination recedes faster than the photon can approach. The message is sent, but it is never received. This is why the edge of the observable universe behaves like a horizon, not a physical barrier, but a limit of influence. Just as ships beyond the horizon at sea are hidden not by distance alone, but by the curvature of Earth, so, too, are distant galaxies hidden by the expansion of space. There comes a point where events beyond that horizon can no longer affect us, no matter how much time passes. They are causally disconnected, separated from us not by emptiness, but by the relentless growth of space itself. The analogy of a horizon is deeply apt. When you stand on a beach, the horizon marks the limit of what you can see, but it is not a wall in the ocean. Sail toward it, and it moves with you. In the same way, the cosmic horizon is not fixed in space. It depends on time, on the history of expansion, and on the future trajectory of the universe. And perhaps, I suppose, that is why the edge of the universe feels less like a boundary and more like a relationship, defined by how space, time, and light interact. There is another layer of strangeness here. The expansion of the universe is not slowing down. Observations suggest it is accelerating, driven by something we call dark energy. We do not yet know what dark energy is. We can describe its effects, measure its influence, but its nature remains one of the deepest mysteries in physics. What we do know is that it causes distant regions of space to accelerate away from one another, and this acceleration has profound consequences for the fate of the observable universe. As expansion accelerates, more and more galaxies cross the cosmic horizon. They fade, not because they burn out, but because the space between us grows too quickly. Over immense spans of time, the night sky would change dramatically for any observer. Galaxies beyond our local group would slip away, one by one, until only a few nearby companions remain visible. The universe would appear quieter, emptier, even though in reality it remains vast and active beyond the horizon. This raises a quietly unsettling thought. The observable universe is not only limited, it is shrinking in a certain sense, not in size, but in content. The number of galaxies we can observe decreases as cosmic time advances. We live at a special moment, one in which the universe is old enough for complex structures to exist, but young enough that much of it is still visible. That balance will not last forever, and perhaps, that gives our era a kind of fleeting significance. We are here while the universe is still speaking loudly to us. At the edge of the observable universe, space behaves almost like a flowing river, carrying distant regions away from our reach. The farther out you go, the stronger the current becomes. Near us, gravity anchors matter against the flow. Far away, the current dominates. Galaxies are swept along, not because they choose to move, but because the riverbed itself is stretching beneath them. And light, ever faithful, tries to swim upstream, sometimes succeeding, sometimes failing, depending on how fast the current grows. This picture helps clarify why galaxies can disappear from view without ever crossing a physical boundary. There is no moment when a galaxy reaches a sign that says, "Beyond this point you cannot be seen." Instead, its light gradually reddens, its signal weakens, and eventually it fades below detectability. The process is smooth, continuous, almost gentle, yet the consequence is absolute. Once beyond the horizon, no new information from that galaxy can ever reach us again. And here, the idea of faster-than-light recession takes on a philosophical weight. It tells us that the universe contains regions that are not just distant, but fundamentally disconnected, not separated by empty space that could, in principle, be crossed, but by the dynamic structure of space-time itself. These regions are not part of our causal network. They cannot influence our future, and we cannot influence theirs. They exist in parallel silence. At the same time, this does not mean the laws of physics break down at the edge. Quite the opposite. Everything we observe there behaves exactly as our best theories predict. The expansion, the redshift, the horizons all follow from well-tested equations. The strangeness lies not in any violation of law, but in the implications of those laws when applied on the largest scales imaginable. The universe is doing precisely what it should. It is our intuition that struggles to keep up. As we consider space expanding ever more rapidly near the horizon, we are forced to rethink what it means for something to be part of our universe. Is the universe defined by everything that exists, or by everything that can, even in principle, affect us? From a physical standpoint, causality matters. If something can never influence us, then for all practical purposes, it lies outside our cosmic domain. And yet, from a philosophical standpoint, we know it may still exist, obeying the same laws, unfolding its own story beyond our reach. This tension between existence and observability sits at the heart of cosmology. The expanding universe teaches us that reality is larger than what we can see, and that the boundary between known and unknown is not static, but evolving. The edge of the observable universe is not a fixed border drawn once and for all. It is a moving frontier, shaped by expansion, acceleration, and time. As time passes, the horizon changes its character. Early in the universe, expansion was slower, and light from increasingly distant regions could eventually reach any given point. Later, as dark energy began to dominate, horizons formed that permanently cut off parts of the cosmos. This means that the universe has not always had the same observable limits, and it will not always have the same ones in the future. The edge we describe is specific to our cosmic epoch, and perhaps this is where the story begins to turn inward. Because if space itself is dynamic, if expansion reshapes horizons and alters what can be seen, then the edge of the observable universe is not just about distance, but about time's passage. Galaxies drift in and out of view as the universe ages. The horizon is not merely a spatial boundary, but a temporal one, changing as the cosmic clock ticks forward. As we follow this line of thought, it becomes clear that the edge is never truly at rest. It shifts, it evolves, it responds to the ongoing expansion of the universe. A galaxy visible today may vanish tomorrow in cosmic terms. Another may emerge from beyond the horizon as light finally arrives. The edge is alive with change. And it is this restless nature of the cosmic boundary, this sense that the horizon itself moves and transforms with time, that draws us naturally toward the next question. If space is expanding and horizons are shifting, then the edge of the universe cannot be fixed or permanent. It must be something far more dynamic, something that changes as the universe ages, inviting us to consider how the edge itself moves, transforms, and reshapes our view of reality as time continues its quiet, unstoppable flow. And so the idea slowly settles in that the edge of the universe, this horizon shaped by light and expansion, is not a static feature etched into the cosmos. It is restless. It shifts. It evolves with time itself. The edge of the observable universe is not fixed in place like a fence post hammered into the ground. It is more like a shadow, always present, yet always changing its position as the sun moves across the sky. When we say the edge of the universe is not fixed, we are really saying something profound about the nature of reality. The boundary of what we can see depends on when we are looking. At earlier times in the universe, the observable region was smaller, not because the universe itself was smaller in extent, but because light had less time to travel. As time passed, photons from ever more distant regions were able to reach observers, expanding the visible cosmos. In that sense, the edge moved outward, carrying new regions of space into view. Yet at the same time, another process was unfolding quietly alongside this expansion of visibility. Space itself was stretching, accelerating under the influence of dark energy. And this stretching does something subtle, but decisive. It creates horizons that permanently cut us off from parts of the universe. So while the observable universe grows in one direction of time, it also shrinks in another sense, losing contact with regions that were once visible. This is the paradox of the cosmic edge. It both advances and retreats. You see, the edge of the observable universe is defined by a balance between two competing processes. On one side, time allows light to travel farther, bringing distant regions into view. On the other, expansion increases the distance light must cross, sometimes faster than light itself can manage. The position of the edge at any given moment is the outcome of this cosmic tug-of-war. And because both time and expansion continue to evolve, the edge is never truly still. This means that a galaxy can occupy a strange and temporary status. There may have been a time when it lay beyond our observable universe, hidden from view because its light had not yet arrived. Then, as time passed, its photons finally reached us, and the galaxy entered our cosmic awareness. For a while, it became part of our observable universe, contributing its light to our telescopes and our theories. But later still, as expansion accelerated, that same galaxy could begin to fade. Its light would stretch and weaken, its signals arriving more slowly, until eventually no new information could reach us at all. The galaxy would cross the horizon once more, this time disappearing from view forever. And perhaps, there is something quietly poetic about that. The universe does not simply reveal itself more and more over time. It reveals and conceals in equal measure. There are chapters of cosmic history that open briefly before closing again, leaving us with memories encoded in ancient light. The edge of the universe is not a one-way door, but a shifting threshold. As the universe grows older, the distance to the edge of the observable universe changes. In terms of the proper distance, the actual separation measured along space at a given cosmic time, the edge moves farther away. Space has had more time to expand, so the regions we can see now are vastly farther from us than the regions visible to the earliest observers. The observable universe today is enormous compared to what it once was, and yet, the set of events that can ever influence us is shrinking. The future horizon is closing in, limiting what can still communicate with us. This dual behavior can feel deeply counterintuitive. We tend to think of the universe as either opening up or closing down, expanding or contracting. But here, both are happening at once, depending on how we define our terms. Distance grows, visibility changes, causality tightens its grip. The edge slides outward in space, even as it tightens inward in time. And so the edge of the universe becomes a dynamic feature, not just of space, but of history. It depends on when you ask the question. An observer living billions of years ago would have described a very different observable universe from ours, even though the underlying cosmos may have been the same. An observer living billions of years in the future would see a different one again, perhaps lonelier, quieter, with fewer galaxies lighting the sky. The edge is not an absolute. It is an experience. This realization forces us to rethink what it means for something to be observable. Observation is not just about having powerful enough instruments. It is about timing. There are windows in cosmic history when certain observations are possible, and outside those windows they are not. We happen to live at a moment when the cosmic microwave background is still visible, when distant galaxies still grace the night sky, when the universe is transparent enough to tell much of its story. That was not always the case, and it will not always be so. The idea that the edge moves also challenges the way we imagine maps of the universe. We are tempted to draw a circle around everything we can see and label it the observable universe, as if that circle were a fixed boundary. But in reality, that boundary is more like a breathing surface, expanding and contracting depending on the cosmic era. Each moment redraws the map. Each passing epoch redefines what lies within and what lies beyond. And there is something deeply humbling in that. Our cosmic maps are provisional. They are snapshots taken at a particular time, not final atlases of reality. The universe does not freeze itself for our convenience. It continues evolving, indifferent to our need for stable reference points. Consider again the galaxies that drift out of view. When one crosses the horizon, it does not vanish in any dramatic sense. There is no flash, no sudden disappearance. Instead, its light becomes increasingly redshifted. Each photon arrives stretched a little more than the last. The intervals between arrivals grow longer. Eventually, the signal becomes so weak and so slow that it blends into the background, indistinguishable from noise. The galaxy is still there, shining as it always has, but its voice can no longer reach us. Silence falls, not because the source is gone, but because the connection has been severed. This gradual fading reminds us that the universe does not enforce its boundaries harshly. It allows things to slip away gently. The edge does not slam shut. It drifts. And this drift is continuous, happening all around us, all the time. Even now, as you listen to this, there are galaxies whose last photons are washing over Earth for the final time, completing journeys that began billions of years ago. At the same time, there are regions just beyond our current horizon, whose light is slowly making its way toward us. They are still invisible, still outside our observable universe, but not forever. Given enough time, some of them will emerge into view, adding new structure to our cosmic picture. The edge is thus not merely a line of loss, but also a line of anticipation. This interplay between gain and loss gives the observable universe a kind of temporal texture. It is not just a spatial volume, but a region defined by history and fate. What lies within it now is the result of countless past expansions and countless future separations. The edge marks not only how far we can see, but how long we can remain connected. As the universe ages further, the balance will continue to shift. Dark energy will drive ever faster expansion. Horizons will harden. Fewer new regions will enter our observable universe, while more will slip away. The edge will still exist, still move, but its character will change. It will become less a frontier of discovery and more a boundary of isolation. And perhaps, I suppose, that realization carries an emotional resonance. There is a fleeting quality to our cosmic moment. We are alive at a time when the universe is generous with its light, when much of its vastness is still within reach. Future observers may not be so fortunate. Their skies may be emptier, their maps smaller, their sense of cosmic connection diminished, even though the universe itself remains immense beyond their horizon. This brings us back to the idea that the edge of the universe is not an object, but a relationship. It reflects how the universe evolves and how observers are embedded within that evolution. It is shaped by expansion, time, and the finite speed of light, but also by the simple fact that observers exist at particular moments, not all moments at once. The edge is dynamic because the universe is dynamic. Space stretches, time flows, light travels, And from the interplay of these emerges a boundary that is always in motion. It shifts, not because the universe is unstable, but because it is alive with change. Every second, the cosmic horizon adjusts itself, recalculating what is visible and what is not. And as we follow this moving boundary, we begin to notice something else. The farther we look toward the edge, the farther back in time we see. The motion of the horizon is inseparable from the flow of time itself. Each change in what we can observe corresponds to a change in which epoch of the universe we are witnessing. The edge is not just moving through space, it is sliding along the timeline of the cosmos. This realization gently leads us onward. If the edge of the universe shifts with time, if galaxies appear and disappear as horizons evolve, then looking toward the edge is also an act of looking into the deepest past. The boundary of space becomes a boundary of history. And at that boundary, time and space begin to intertwine in ways that challenge our everyday understanding, inviting us to consider how, at the very edge of the universe, time itself bends, stretches, and reveals the oldest memories the cosmos has to offer. And so, as the moving edge of the universe slides across space, reshaping what can be seen and what must remain hidden, we arrive at a deeper realization. To look outward toward that edge is not merely to look far away. It is to look back, far back as the universe will allow us. Because at these immense distances, space and time are no longer separate ideas. They are entwined, inseparable threads of the same cosmic fabric. When your eyes rest on the faintest glow near the horizon of the observable universe, you are not witnessing a distant place as it exists now. You are witnessing an ancient moment, preserved and delivered across billions of years. The edge of the universe is, in this sense, a time machine. Every additional unit of distance corresponds to an earlier chapter in cosmic history. Nearby galaxies show us a universe already mature, rich with structure and complexity. But as we look farther, that complexity slowly unravels. Galaxies grow smaller, more chaotic. Stars become rarer. Order gives way to youth. And that is the thing. Time does not flow uniformly across the cosmos in the way our everyday experience might suggest. On cosmic scales, time is woven together with space. The farther away we look, the younger the universe becomes. At the edge of what we can observe, we see the universe not as it is now, but as it was when it had barely begun to take shape. The edge of space becomes the edge of time. This idea can feel disorienting at first. We are accustomed to thinking of time as something that passes here and now, measured by clocks, marked by memories. But in cosmology, time reveals itself spatially. Distance is history. Light from faraway regions has taken so long to reach us that it carries with it the conditions of an era long gone. When astronomers speak of looking back billions of years, they mean it quite literally. They mean looking outward. Near the cosmic horizon, we encounter the youngest light that can reach us. Not young in age as we might think of a newly ignited star, but young in cosmic terms, originating from a universe still in its infancy. This light left its source when matter had only recently cooled enough to form atoms, when the universe had only just become transparent. Before that moment, light could not travel freely. Space was filled with a dense, opaque plasma. Time existed, of course, but it left no visible trace we could ever detect. This makes the edge of the observable universe a kind of archival boundary. It is the oldest record we can ever hope to read. Every photon arriving from near that horizon carries with it a timestamp from the early universe. By collecting and analyzing these photons, scientists reconstruct a detailed narrative of cosmic evolution. Subtle variations in temperature, tiny differences in density, all become clues. The edge becomes a library of ancient light, a fossil record written not in stone, but in radiation. And yet, as precise as this record is, it is incomplete. There is a before that we cannot see, a time earlier than the earliest light. Physics tells us that events occurred before the universe became transparent, but those events are hidden behind an observational veil. No matter how advanced our instruments become, they cannot see beyond that boundary using light alone. The universe has drawn a line through time itself, and beyond it, direct observation fails. This is where space and time truly merge. The limit is not a distance you could overcome with better technology or faster travel. It is a temporal boundary. To see earlier than that moment would require messengers other than light or entirely new ways of probing reality. The edge of the universe thus represents not only the limits of our sight, but the limits of our access to the past. When we say that time bends at the edge of the universe, we do not mean that clocks run strangely there in the everyday sense. We mean that our intuitive separation between past and present dissolves. The farthest regions we observe are locked into an ancient state, forever frozen at the moment their light was released. Those regions may have evolved dramatically since then, forming stars, collapsing galaxies, perhaps even worlds and life. But none of that later history can reach us. For us, those regions are eternally young. And there is something haunting about that. Parts of the universe we see will never grow old in our eyes. They will never mature. They will never reveal what they become. They are suspended in time, not because time has stopped for them, but because information about their future is permanently inaccessible. The universe contains stories that begin but never finish, at least not for us. This also means that when we map the universe, we are assembling a collage of different epochs. The nearby universe shows us a late stage of cosmic evolution. Farther out, we see adolescence. Near the edge, we see infancy. All of these times coexist in our view of the sky. The universe presents its entire life story at once, laid out across space. It is a deeply strange perspective, one that no creature confined to a single moment in time could have anticipated. And perhaps, I suppose, this is why cosmology feels so profoundly philosophical. It forces us to confront the fact that the present moment is not universal. What is now for us is long past for distant galaxies. What is now for them may never be now for us. The concept of a single cosmic present dissolves. Instead, we inhabit a space-time mosaic, stitched together by light. At the edge of the observable universe, this mosaic reaches its earliest tile. The light we see there comes from a time when the universe was remarkably uniform. Small fluctuations existed, tiny seeds of future structure, but overall, matter and energy were distributed with astonishing smoothness. This is the universe at its most pristine. By studying this ancient light, scientists learn not only about the universe's beginning, but about the rules that governed its earliest moments. Each photon from that era carries imprints of the conditions under which it was formed. Its energy, its direction, its subtle correlations with other photons all encode information about the density of matter, the geometry of space, the rate of expansion. In this way, the edge of the universe becomes a kind of cosmic Rosetta Stone. It allows us to translate the language of the early universe into the structures we see today. And yet, the farther back we look, the stranger the universe becomes. Familiar concepts begin to lose their meaning. Temperature, density, even the distinction between particles and radiation blur. Time itself behaves differently when the universe is extremely young. Near the beginning, the scales involved are so extreme that our current theories struggle to describe them fully. General relativity and quantum mechanics, both extraordinarily successful in their domains, begin to conflict. This is another sense in which time bends at the edge of the universe. Our theoretical descriptions curve and strain under the conditions of the early cosmos. The smooth flow of time assumed in everyday physics gives way to something more complex. Space and time may have emerged together from a deeper, more fundamental reality. The edge of the observable universe brings us face to face with the limits of our understanding, not because we lack data, but because the concepts we rely on begin to break down. Looking toward that edge, we are peering into a regime where cause and effect may not behave as we expect, where familiar notions of before and after lose clarity, where the universe itself was still settling into the form we now recognize. The farther back we look, the more we sense that time is not an external backdrop, but an active participant in cosmic evolution. And this has profound implications for how we understand history itself. The universe does not simply exist in time. Time is part of what the universe is. When we look toward the edge, we are not just looking at old objects. We are looking at old space-time. The geometry, the expansion rate, the physical laws themselves may have been subtly different then. The edge becomes a window into a version of reality that no longer exists anywhere we can reach. At the same time, this ancient light is astonishingly fragile. It has traveled across an expanding universe for billions of years, stretched, cooled, diluted, and yet it still arrives, still carries meaning, still allows us to reconstruct events from the deepest past. There is something almost miraculous in that endurance. The universe remembers its beginnings, and it shares those memories with us through light. But there is also loss here. For every photon that reaches us, countless others have been scattered, absorbed, or stretched beyond detectability. The record is incomplete. There are gaps we can never fill. And perhaps you know, that incompleteness is part of the beauty. The universe offers us clues, not certainties. It invites us to reconstruct its story, knowing we will never have the full script. As we approach the edge of time through observation, we begin to see that the universe's history is layered. Early simplicity gives rise to later complexity. Small fluctuations grow into galaxies, stars, planets. The edge holds the seeds of everything that follows. In that sense, the boundary of the observable universe is not just the end of our vision, but the beginning of cosmic structure. And here, our attention naturally shifts again. Because the early universe we glimpse near the edge is not simply a smooth glow. It contains subtle irregularities, tiny variations that hint at the structures to come. These irregularities are the ancestors of galaxies, clusters, and vast cosmic webs. To understand what we see near the edge, we must understand how matter organized itself over time. The edge of the universe is thus not only a record of time, but a prelude to structure. It shows us the universe before order fully emerged, before gravity sculpted matter into the familiar forms we see nearby. And as we follow these faint imprints forward in time, tracing how they evolved into the complex cosmos around us, we are led naturally to the next mystery. What does the universe look like near the edge, not just in age, but in form? How does structure itself change as we approach the earliest times, and what strange, unfinished patterns await us there, at the threshold where the familiar order of the universe has not yet taken shape? And so, following the faint imprints left by time itself, we find that the universe near its edge does not merely look younger. It looks unfinished. In these distant regions, structure has not yet settled into the elegant patterns we recognize nearby. The closer we peer toward the horizon of observation, the more the universe seems to loosen its familiar order, revealing a cosmos still in the midst of becoming. Galaxies near the edge of the observable universe often appear strange to our eyes. They do not display the graceful spiral arms or well-defined elliptical shapes we see closer to home. Instead, many look distorted, irregular, clumpy, as though they are caught mid-transformation. Some appear stretched, others fragmented, their stars scattered in uneven knots. This is not because physics behaves randomly there, but because the universe has not yet had time to settle into the stable arrangements we associate with maturity. You see, structure in the universe takes time. Gravity must slowly gather matter together, overcoming the expansion of space. Small fluctuations grow larger, collapsing into halos of dark matter, pulling gas inward, igniting stars. This process unfolds over immense timescales. Near us, the universe has had billions of years to refine its architecture. Near the edge, it has not. We are witnessing a universe still learning how to build. And that is the thing. When we look toward the edge, we are not looking at a representative sample of cosmic structure. We are looking at a work in progress. Galaxies are smaller, less massive, more chaotic. Many have only recently begun forming stars. Some may host intense bursts of star formation, blazing brightly for a short time before fading. Others may be assembling through collisions and mergers, their shapes disrupted by gravitational encounters that have not yet settled. The large-scale structure of the universe also appears different near the edge. Nearby, matter traces out a vast cosmic web, with galaxies arranged along filaments and walls surrounding enormous voids. This web is the product of billions of years of gravitational evolution. Near the edge, that web is thinner, less pronounced. Filaments are present, but they are less defined. Voids exist, but they are not yet as empty or as expansive. The universe there is rougher, less sculpted, as though the chisel of gravity has only just begun its work. Matter itself behaves differently in this early epoch. Gas has not yet cooled and condensed as thoroughly. Heavy elements forged in stars are rare, because there have not yet been many generations of stellar life and death. The chemical richness we take for granted nearby simply does not exist. Planets, if they exist at all in these regions, would be profoundly different from anything we know. The raw materials for complexity are scarce. The universe is chemically young. This scarcity shapes everything. Stars form under different conditions, often more massive and short-lived. Their light is harsher, more intense. When they die, they enrich their surroundings. But the process is just beginning. The early universe is a place of extremes, where formation and destruction occur rapidly, driven by the abundance of pristine gas and the absence of stabilizing structures. And perhaps, this gives the edge of the universe a certain wildness. It is not a calm frontier, but a turbulent one. The familiar balance we see locally between star formation, galactic rotation, and gravitational stability has not yet emerged. Near the edge, galaxies collide frequently, merge often, reshape themselves again and again. Order is temporary, change is constant. Even the distribution of empty space is different. Large voids appear more frequently, but they are less cleanly defined. These vast regions, containing little matter, are a natural consequence of gravitational growth. But near the edge, they are still forming. Matter has not yet fully drained into filaments and clusters. The universe is more uneven, more lumpy, with density contrasts that are still evolving. The absence of familiar order near the edge reminds us that the universe did not always look the way it does now. The calm night sky we see is the result of a long history of self-organization. Gravity, working patiently over billions of years, has transformed a nearly uniform early universe into a richly structured one. Near the edge, we are witnessing the earlier chapters of that story, before coherence fully emerged. And, there is something deeply instructive in this. It tells us that the laws of physics do not guarantee immediate order. They provide the rules, but time is required for patterns to form. The edge of the observable universe shows us physics in its rawest creative phase, before repetition and stability have smoothed out the rough edges. Galaxies near the edge often appear smaller not because they are inherently limited, but because they have not yet grown. Growth requires mergers, accretion, and time. Many of these galaxies will one day become massive systems, perhaps resembling those we see nearby, but we will never witness that transformation. For us, they remain forever young, locked into their early forms by the finite speed of light. This eternal youth gives the edge a peculiar character. It is not simply distant. It is perpetually immature. Regions of the universe we observe there will never age in our view. They will never settle into equilibrium. They will always appear chaotic, not because they are intrinsically chaotic, but because we are seeing them at the moment before order fully takes hold. The cosmic web itself near the edge is like a sketch rather than a finished painting. Filaments exist, but they are thinner, less populated. Clusters are smaller, less massive. Superclusters, those immense gatherings of galaxies, are rare or incomplete. The grand architecture of the universe is still assembling. Gravity is still drawing its lines. and this has implications for how we interpret what we see. The universe near the edge cannot be understood simply by extrapolating from nearby structures. It requires models that account for rapid change, intense star formation, frequent mergers. It is a universe in flux. And this flux is not noise. It is signal. It tells us how complexity emerges from simplicity. Perhaps, I suppose, there is also a quiet emotional resonance here. When we look toward the edge, we are seeing a universe that has not yet become what we know. It is a reminder that the order we experience is not inevitable. It is contingent. It required time, stability, and the slow accumulation of structure. The cosmos we inhabit is not the only possible outcome, but one that emerged from a long and delicate process. The strange structures near the edge also challenge our categories. What counts as a galaxy when stars are just beginning to assemble? What counts as a cluster when gravitational binding is incomplete? The familiar labels we use nearby become blurred. The universe resists neat classification at its earliest times. It is experimenting, and that experimentation leaves traces we can still detect. Irregular shapes, asymmetric distributions, unexpected alignments. These are not flaws in our observations. They are fingerprints of youth. They tell us that the universe did not spring fully formed into existence. It grew, stumbled, adjusted, and refined itself. As we study these early structures, we begin to appreciate the role of dark matter more clearly. Near the edge, dark matter dominates the formation of structure even more strongly than it does nearby. Its gravitational influence shapes the scaffolding upon which visible matter later accumulates. The luminous universe we see is merely a tracer, lighting up the deeper invisible framework. Near the edge, that framework is more apparent because the visible structures are so incomplete. This reinforces a humbling idea. Much of the universe's structure is hidden from direct view. What we see in light is only part of the story. Near the edge, this becomes especially clear. The visible universe is sparse, uneven, transient. Beneath it lies a more substantial, unseen architecture guiding its evolution. The absence of familiar order near the edge also means that the physical conditions there can be extreme. Temperatures can vary dramatically. Radiation fields are intense. Feedback from massive stars and early black holes can reshape entire galaxies. Stability is rare. Equilibrium is temporary. The universe is loud, energetic, restless. And yet, within this chaos, the seeds of everything we know are present. The early irregularities grow into galaxies. The primitive filaments thicken into cosmic highways of matter. The chaotic interactions eventually settle into rotating disks, stable orbits, long-lived stars. The edge of the universe shows us the beginning of that transformation. This realization gently shifts our perspective. The strange structures near the edge are not anomalies. They are ancestors. They are what our own cosmic neighborhood once looked like, long before Earth formed, long before stars like the sun existed. To look toward the edge is to look at our own deep past, not just in time, but in form. And that makes the edge feel oddly intimate. It is distant beyond comprehension, yet it shows us something profoundly familiar. It shows us what the universe was before it became the place we recognize. It shows us the raw conditions that eventually allowed complexity, chemistry, and perhaps life to emerge. As we push our observations closer to the edge, we also push our theories. The strange structures we see challenge our models of galaxy formation. They force us to refine our understanding of how matter behaves under extreme conditions. They remind us that our theories are approximations, tuned to the universe we know, not necessarily the universe as it once was. And this is where a subtle unease begins to appear. If structure near the edge is so different, if matter behaves so strangely, then perhaps the physical laws themselves are being tested. Perhaps the assumptions we make, based on local observations, begin to falter. The universe near the edge does not just look unfamiliar. It hints that the rules we rely on may be approaching their limits of applicability. As structures grow simpler and conditions grow more extreme, the comfortable reliability of our equations begins to feel less certain. Gravity dominates, but in ways that challenge intuition. Temperature and density fluctuate wildly. The smooth approximations that work nearby start to break down. And so, as we contemplate these strange, unfinished structures near the edge, we are naturally led onward. Because if the universe near the edge lacks familiar order, if its structures are crude, chaotic, and incomplete, then what does that say about the laws governing them? Do our trusted physical principles still apply in the same way? Or are we approaching a regime where physics itself begins to behave strangely, where certainty gives way to approximation, and where the edge of the universe becomes not just a frontier of observation, but a frontier of understanding itself? And so, as we linger at the edge where structure itself feels unfinished, where galaxies are crude sketches, and order has not yet settled, a deeper unease quietly emerges. It is not just that the universe looks strange there. It is that our confidence begins to waver. The familiar rules we rely on, the equations that have guided us so faithfully through stars and planets and nearby galaxies, start to feel less secure. Near the edge of the observable universe, physics itself begins to hesitate. You see, the laws of physics we know are built on observation. They are refined, tested, and trusted because they describe what we can measure. But near the cosmic edge, we are pushing those laws into regimes they were never directly tested to handle. Immense scales, extreme energies, conditions that existed when the universe was young, dense, and rapidly changing. In these environments, our equations still work remarkably well, but not perfectly. Subtle discrepancies begin to appear. Approximations stretch thin. Certainty softens into probability. Gravity, the quiet architect of cosmic structure, is a good place to begin. Nearby, gravity behaves predictably. It pulls matter together, shapes orbits, binds galaxies into clusters. Einstein's description of gravity as the curvature of space-time has passed every test we have thrown at it, from planetary motion to black holes. And yet, on the largest scales, near the edge of the observable universe, gravity's role becomes harder to pin down. The distribution of matter at these distances is uneven and evolving. Dark matter dominates, but its precise behavior remains elusive. We infer its presence through gravitational effects, yet we do not know its true nature. Near the edge, where visible matter is sparse and structures are incomplete, gravity operates in a regime where small uncertainties can have large consequences. Our models depend on assumptions about how matter clusters, how density fluctuations grow, how space-time responds on enormous scales. And here, those assumptions begin to feel fragile. Then there is the expansion of the universe itself. The acceleration driven by dark energy is one of the greatest puzzles in modern physics. We can measure its effects with astonishing precision, yet we do not understand its origin. Near the edge of the observable universe, dark energy shapes the fate of entire regions of space-time. It determines which galaxies remain visible and which slip away forever. It influences the geometry of the universe on the largest scales, and yet we describe it with a placeholder, a term in an equation that captures behavior without explaining cause. This is where physics begins to feel provisional. We know what happens. We do not know why. Near the edge, that gap becomes impossible to ignore. The universe is behaving in ways that are consistent with our equations, but the meaning behind those equations remains hidden. It is as if we can hear the melody clearly, but the instrument producing it remains out of sight. Temperature and density also behave in extreme ways near the cosmic horizon. In the early universe, conditions were far hotter and denser than anything we can recreate or observe nearby. Matter existed in states unfamiliar to everyday physics. Particles interacted constantly. Radiation dominated over matter. Under such conditions, the neat separations between forces and particles blur. Quantum effects become significant on cosmic scales. Classical descriptions lose their sharpness. And that is the thing. Our two great pillars of physics, general relativity and quantum mechanics, excel in their own domains. One describes the very large, the other describes the very small. But near the edge of the universe, in its earliest moments, both are relevant at once. Gravity is strong. Densities are immense. Quantum effects cannot be ignored, and yet we do not possess a complete theory that unites these frameworks. Near the edge, the universe seems to be asking questions our physics is not yet prepared to answer. This does not mean that the laws of physics suddenly break. It means that our descriptions become incomplete. The models we use rely on extrapolation, extending well-tested theories into regimes we cannot directly verify. Most of the time, this works beautifully. The cosmic microwave background, for example, matches predictions with astonishing accuracy. But there are hints, small anomalies, subtle tensions between measurements that suggest something is missing. These tensions are not failures, they are invitations. They tell us that near the edge of the observable universe, we are brushing up against the limits of our understanding. The universe is not misbehaving. It is revealing that our current picture, while powerful, is not yet final. Even concepts as fundamental as space and time may behave differently under these extreme conditions. Near the beginning of the universe, space-time itself may have fluctuated quantum mechanically. The smooth continuum we assume may have been replaced by something granular, something foamy, something that defies classical intuition. Near the edge, when we look back far enough, we are peering into an era where the very notion of a smooth space-time may no longer apply. This has profound implications. If space and time emerge from deeper principles, then the edge of the observable universe marks not just the boundary of sight, but the boundary of classical reality. Beyond that, the universe may still exist, but in a form we cannot easily describe. Our equations, built on continuity and smoothness, begin to lose their footing. And there is something deeply humbling in this. We often speak of physical laws as immutable, eternal truths. But near the edge, we are reminded that laws are models, descriptions crafted by human minds to capture patterns in nature. They are extraordinarily successful, but they are not the universe itself. The universe is richer, stranger, and more subtle than any equation we write down. Consider also the role of uncertainty. In quantum mechanics, uncertainty is fundamental. It is not a limitation of measurement, but a property of reality. Near the edge of the universe, where quantum effects may have influenced the large-scale structure of space-time, uncertainty may play a role on cosmic scales. Tiny fluctuations in the early universe were amplified by expansion, seeding galaxies and clusters. Randomness, woven into the fabric of reality, shaped the cosmos we see today. This means that the universe near the edge is not just extreme, but inherently unpredictable in detail. We can describe its statistics, its averages, its broad behavior. But the exact configuration of structures, the precise distribution of matter, may be fundamentally unknowable. The universe does not offer a complete blueprint, it offers probabilities. As we push our theories toward the edge, mathematical models become more complex and less certain. Assumptions that hold nearby may no longer apply. Symmetries may break. Simplifications fail. Physicists must introduce new parameters, new fields, new ideas to make sense of the data. Each addition improves the fit, but also raises new questions. Are these features real, or are they artifacts of our incomplete understanding? And perhaps, I suppose, this is where the philosophical weight of cosmology becomes unavoidable. At the edge of the universe, science confronts its own limits. Not limits imposed by lack of intelligence or effort, but limits imposed by the structure of reality itself. There may be aspects of the cosmos that can never be fully known, not because we have not tried hard enough, but because information cannot reach us, or because the concepts we use no longer apply. This does not diminish science. It enriches it. It reminds us that knowledge is a journey, not a destination. The edge of the universe is not a failure of understanding, but a frontier where understanding must evolve. Near the edge, even the notion of cause and effect becomes subtle. Events are separated by such immense stretches of space-time that causal connections weaken and eventually disappear. Regions fall out of contact forever. The universe fragments into causally isolated domains. Within each, physics unfolds consistently, but between them, there is silence. This challenges our intuitive sense of a single connected cosmos. And yet, we infer that the same laws apply everywhere, even beyond our horizon. This assumption, called cosmological principle, is deeply ingrained in our models. It has served us well, but near the edge, it remains an assumption, a reasonable one, perhaps even a beautiful one, but not one we can directly test. The universe asks us to trust that its rules do not abruptly change beyond our sight, even as it withholds direct confirmation. As temperature and density vary wildly near the edge, phase transitions may occur. Forces that are distinct today may have been unified in the early universe. Symmetries may have broken as the universe cooled, shaping the properties of particles and forces. These processes leave subtle imprints in the cosmic structure, imprints we can sometimes detect, but not always fully decode. The early universe is like a laboratory whose experiments ran once at energies we cannot reproduce. This uniqueness adds to the uncertainty. In a laboratory, experiments can be repeated, parameters can be adjusted. Near the edge of the universe, we have only one data set, one cosmic history. We infer laws from a single realization. That realization is vast and rich, but it is still one. This makes cosmology both powerful and precarious. And perhaps that is why discussions of the edge of the universe often feel speculative, not because they are careless, but because they are honest. They acknowledge that we are extrapolating beyond direct experience, that we are using mathematics as a bridge into the unknown, that some questions may remain open for generations or forever. As we contemplate physics becoming uncertain near the edge, we begin to see the boundary not just as a place where observation ends, but where explanation softens, where confident statements give way to careful language, where models are tested to their limits. And yet, even here, the universe continues to offer guidance. Patterns persist, regularities remain. The cosmos does not dissolve into chaos. It remains intelligible, even if not fully understood. There is order at the edge, but it is an order that challenges us to expand our frameworks, to rethink our assumptions, to accept that certainty may never be absolute. This sense of approaching a limit, not of space or time, but of comprehension itself, naturally invites a deeper question. If physics begins to feel uncertain near the edge, if our laws are stretched and strained, then what does that say about the edge itself? Is it a real feature of the universe, or a construct arising from the way we observe and interpret reality? Does the universe truly have an edge at all, or is it something that exists only in our descriptions, shaped by light, time, and the limits of understanding? And with that question gently forming, our attention is drawn onward, beyond physics as we know it, toward the deeper inquiry of whether the edge we have been tracing is a fundamental property of the cosmos, or a reflection of our own place within it. And so we arrive at a question that feels almost inevitable now, hovering gently at the edge of everything we have explored. After light, expansion, time, structure, and the growing uncertainty of physical law, we are compelled to ask something more fundamental. Does the edge of the universe truly exist at all, or is it something we have conjured from the limits of our perception, a shadow cast by the way we observe reality rather than a feature of reality itself? You see, throughout history, humans have always imagined edges: the edge of the earth, the edge of the ocean, the edge of the sky, each and no edge. Every region looks much like every other on sufficiently large scales. The observable universe would then be just one small patch of an unimaginably vast whole. Beyond our horizon would lie more galaxies, more stars, more structures, repeating the same patterns over and over, perhaps endlessly. This possibility carries strange implications. In an infinite universe governed by the same physical laws everywhere, there could be regions arbitrarily similar to our own, perhaps even regions where histories unfold in almost the same way. This idea feels almost uncomfortable, brushing against questions of identity, repetition, and meaning. But from a purely physical standpoint, it is not forbidden. Infinity does not care about our discomfort. And yet, we must be careful. Infinity is a dangerous concept in physics. It often signals that our theories are being pushed beyond their reliable domain. When equations produce infinities, physicists usually suspect that something deeper is missing. So while an infinite universe is mathematically possible, whether it truly exists remains an open question. What complicates matters further is that we cannot observe the universe as a whole. We are trapped within our observable patch, constrained by light and time. No experiment can directly tell us whether space curves back on itself or stretches on forever. We infer the global properties of the universe indirectly, through subtle measurements of geometry, expansion, and cosmic background radiation. These measurements suggest that the universe is very close to geometrically flat, but close is not the same as exact. A slight curvature could exist beyond our current ability to detect. This leaves us in a peculiar position. The universe may have an edge. It may not. It may be finite. It may be infinite. And science, for now, cannot decisively choose between these possibilities. The edge of the universe becomes a question not of observation, but of interpretation. Some philosophers and physicists have suggested that the idea of an edge is fundamentally flawed, that the universe is not the kind of thing that can have a boundary, that asking what lies beyond the universe is like asking what lies north of the North Pole. The question assumes a structure that may not exist. In this view, the universe simply is. It does not need an outside. And perhaps, this perspective invites a certain humility. It reminds us that not every question framed in human terms corresponds to a meaningful feature of reality. Some questions dissolve when examined closely. The edge of the universe may be one of them. At the same time, the concept of an edge persists stubbornly because it captures something real about our experience. We do encounter limits. We do reach horizons beyond which information cannot pass. These limits shape our science, our philosophy, our sense of place. Even if the universe has no edge in an absolute sense, it has edges relative to us, and those edges matter. This tension between objective reality and subjective perspective is at the heart of cosmology. The universe does not arrange itself for our convenience. It does not reveal its global structure easily. We are embedded observers, trying to reconstruct the whole from a part, and in doing so, we inevitably project our intuitions outward. The idea that the edge exists only in human perception does not mean it is an illusion. It means it is relational. It arises from the interaction between the universe and observers like us. Light, time, and expansion conspire to create horizons. These horizons are real in their effects, even if they are not physical walls. And that is the thing. The observable universe has an edge because information is finite, because signals travel at finite speed, because the universe has a finite age. None of these facts are subjective. They are woven into the structure of reality. But the interpretation of that edge as a boundary of existence is something we add. If we imagine an observer elsewhere in the universe, far from our location, that observer would have their own observable universe, with their own edge, centered on themselves. Their edge would not coincide with ours. The universe does not privilege any one viewpoint. Every observer is surrounded by their own horizon. In that sense, the edge is everywhere and nowhere. This realization dissolves the idea of a single, universal boundary. There is no unique edge shared by all observers. There are countless overlapping horizons, each defined by position and time. The universe does not have one edge. It has as many edges as there are observers. And perhaps, I suppose, that is one of the most beautiful insights of modern cosmology. It tells us that the universe is not arranged around us, yet it allows each of us to experience ourselves as central, without contradiction. We are not special, and yet our perspective is valid. The edge we see is real for us, even if it is not absolute. The question of whether the universe is closed, open, or infinite also carries deep philosophical weight. A closed universe suggests a kind of cosmic completeness, a self-contained reality with no outside. An infinite universe suggests boundlessness, an endless unfolding without finality. Each carries different emotional resonances. Each shapes how we imagine existence. Science, however, remains cautious. It follows evidence, not intuition. And the evidence so far allows multiple possibilities. The universe may be finite but unbounded. It may be infinite. It may possess a topology far stranger than any of our simple analogies suggest. Higher dimensional shapes, complex global structures, exotic geometries, all remain on the table. What unites these possibilities is a common theme. The edge of the universe, if it exists, is not something we can approach in space. It is not a destination. It is a property of geometry and causality. It cannot be reached by traveling far enough. It cannot be crossed. It can only be inferred. And this inference is always provisional. As observations improve, models refine. What seems likely today may be revised tomorrow. Cosmology is a young science, grappling with questions of staggering scale. Its humility is one of its strengths. As we sit with this uncertainty, we may notice something subtle happening. The question of the edge is slowly transforming. It is no longer just about space. It is about meaning, about how we define existence, about whether reality must conform to our expectations. And perhaps this is where science and philosophy quietly meet. The universe does not tell us whether it has an edge in a way that satisfies our intuition. It tells us that our access to reality is limited, that our questions are shaped by perspective, and that the cosmos is under no obligation to be neatly bounded. This does not end the inquiry. It deepens it. Because if the universe may not have an edge, then the next question naturally arises. If there is no boundary, no final border, then what lies beyond what we can observe? Not beyond the universe, but beyond our horizon. Are there other regions, other domains, perhaps even other universes, unfolding alongside our own, forever separated by the structure of space-time itself? And with that thought gently taking shape, we find ourselves drawn onward, past the question of whether the edge exists, toward the even more unsettling question of what might lie beyond it. And so, having loosened our grip on the very idea of an edge, having allowed the possibility that the universe may not end at all, we find ourselves standing before a far more unsettling question. If there is no true boundary, if the observable edge is only a horizon shaped by light and time, then what, if anything, lies beyond that horizon? Not beyond the universe in some absolute sense, but beyond what we can ever observe, beyond what can ever speak to us through photons or gravity or any known signal. Here, science must tread carefully, because this is where observation truly fails. The region beyond the observable universe is, by definition, unobservable. No telescope can peer there. No experiment can sample it. Whatever lies beyond our cosmic horizon is forever cut off from direct evidence. And yet, the human mind, restless and curious, refuses to stop at silence. We ask anyway. We imagine. We build theories not from data, but from consistency, symmetry, and mathematical possibility. The first and most conservative answer is also the simplest. Beyond the observable universe, there may simply be more of the same. More galaxies, more clusters, more cosmic web, an extension of the familiar, repeating itself beyond our horizon without end. In this view, our observable universe is just a small patch of a much larger whole, no more special than any other region. The laws of physics continue unchanged. The universe does not notice our horizon. It does not care that light from those regions cannot reach us. This idea is comforting in its simplicity. It suggests continuity rather than rupture. It tells us that the cosmos beyond our view is not alien, merely distant. And perhaps, there is something deeply satisfying about that. The universe does not suddenly become strange just because we cannot see it. It remains what it has always been. But this is an assumption, a reasonable one, grounded in the success of the cosmological principle, the idea that the universe is broadly uniform on large scales. Yet beyond our horizon, uniformity cannot be tested. It must be taken on faith, or at least on theoretical elegance. Other ideas are far more radical. Some suggest that beyond our observable universe lie other regions with different properties, different densities, different rates of expansion, perhaps even different physical constants. In these models, what we call the universe is only one domain within a much larger structure, a patchwork of cosmic regions that never interact. This is where the concept of the multiverse enters the conversation, not as science fiction, but as a serious, if controversial, theoretical proposal. In certain models of cosmic inflation, the rapid expansion that occurred early in the universe may not have happened uniformly. Different regions may have inflated at different rates or stopped inflating at different times. Each region could become a universe in its own right, with its own observable horizon, its own history. In such a picture, our observable universe is one bubble among many. Other bubbles may exist beyond our horizon, separated from us not by distance alone, but by the structure of space-time itself. They may never collide with us. They may never exchange information. They may be causally disconnected forever. And this idea feels both exhilarating and deeply unsettling. Exhilarating because it vastly expands the scope of reality. Unsettling because it challenges the very notion of a single, unified cosmos. The universe becomes plural. Some versions of the multiverse go even further. They suggest that different universes may have different laws of physics, different values for fundamental constants, different particle properties. In such a landscape, our universe would be one of many possible realizations. Its particular features would not be uniquely determined, but selected from a vast menu of possibilities. This idea is often invoked to explain why the universe appears so finely tuned for complexity, why the constants of nature fall within narrow ranges that allow stars, chemistry, and life. In a multiverse, there is no need for deep explanation. We observe these conditions because only universes with such conditions can host observers. The rest exist silently, unobserved, perhaps sterile or radically different. But here, science brushes dangerously close to philosophy, because how do we test the existence of other universes? If they are truly, beyond our horizon, truly causally disconnected, then no observation can ever confirm or refute them. The multiverse becomes a framework that explains everything and nothing at once. It is powerful, but elusive. Some physicists are uncomfortable with this. They worry that science loses its footing when it ventures into realms that cannot be tested. Others argue that testability is not always immediate, that theories once thought untestable can later yield indirect evidence. The debate continues, unresolved, reflecting deeper questions about what science should be. What is clear is that beyond the observable universe, our usual standards of evidence no longer apply. We are forced to rely on inference, consistency, and the internal logic of our theories. We ask not what we can see, but what must exist if our models are correct. And perhaps, I suppose, this is not as new as it seems. Long before telescopes, humans inferred the existence of unseen lands beyond the horizon. They reasoned that the Earth continued beyond what they could see, and they were right. The difference now is scale. The beyond we are contemplating is not just geographically distant, but fundamentally inaccessible. Another possibility is even stranger. It suggests that beyond our horizon, space-time itself may behave differently, that our region of the universe could be embedded within a higher dimensional space. In some theories, our universe is like a membrane floating in a larger dimensional structure. Other regions, other universes, could exist alongside ours, separated not by distance within space, but by dimensions beyond our perception. These ideas arise naturally in certain attempts to unify physics. They are mathematically consistent, even elegant. But again, they remain speculative. Without observational access, they hover in a realm between physics and metaphysics. And yet, the universe has surprised us before. Time and again, what seemed philosophical turned out to be physical. Atoms were once speculative. Galaxies were once thought to be mere clouds within our own. The expansion of the universe itself was once unthinkable. It would be unwise to assume that our current horizons mark the final limits of discovery. Still, for now, beyond the edge of the observable universe, science must speak softly. It must acknowledge what it does not know. It must resist the temptation to declare certainty where none is possible. There is also a quieter, more subtle answer to the question of what lies beyond the edge. It suggests that nothing meaningful lies there, not because nothing exists, but because meaning itself is tied to interaction. If a region can never affect us, can never exchange information with us, then from a physical standpoint, it may as well not exist. Reality, in this view, is defined by causality. Beyond the horizon, there is no causality linking those regions to us. They are physically irrelevant to our universe. This perspective does not deny existence. It reframes it. It says that physics concerns itself with relationships, not absolutes. What matters is not what exists in some ultimate sense, but what can influence what. From that standpoint, the universe effectively ends at the horizon, even if something exists beyond. And this idea carries a certain stark beauty. It reminds us that reality is not just about being, but about connection. A universe is not merely a collection of objects, but a network of interactions. Beyond the horizon, interactions cease. Silence reigns, yet even silence can provoke curiosity. The fact that we cannot know what lies beyond does not extinguish the question. It sharpens it. It forces us to confront the limits of human understanding, not as a failure, but as a defining feature of our place in the cosmos. When we ask what lies beyond the edge, we are really asking what it means to know anything at all. We are asking how knowledge depends on access, on communication, on light. We are asking whether reality must be observable to be meaningful. And perhaps, this is why the question resonates so deeply. It is not just about distant galaxies or hypothetical universes. It is about us, about the scope of our curiosity, about whether the universe is something we can ever fully comprehend, or whether mystery is built into its very structure. The edge of the observable universe marks the boundary of our story. Beyond it, other stories may unfold, or perhaps none that concern us. Science cannot yet say, and so it does what it does best. It holds multiple possibilities in mind, tests what it can, and waits. As we stand at this conceptual horizon, the universe feels larger than ever, not just in size, but in depth. It contains not only what we see, but what we cannot, not only what we can explain, but what remains beyond explanation. And this realization gently turns our gaze inward, because if there are regions forever beyond our reach, if reality extends far beyond our awareness, then what does that say about our place within it? What does it mean to be a thinking creature in a universe that so vastly exceeds our capacity to know it? The question of what lies beyond the edge naturally gives way to another, quieter question. What does the edge mean for us, for our understanding, for our sense of significance within this immense and perhaps unbounded reality? And so, after wandering to the very limits of observation, after loosening our assumptions about edges, horizons, and even existence itself, we find that the question slowly turns back toward us, not toward the stars, not toward hypothetical universes beyond reach, but toward the small, fragile observers asking these questions in the first place. Because the edge of the universe, whether real or perceived, carries a quiet message for humanity. The edge reminds us, first and foremost, of limitation, not in a cruel or diminishing way, but in a profoundly honest one. We live inside a finite bubble of information. Everything we know about the cosmos arrives carried on light, stretched across space and time. Our senses, extended by instruments, are still bound by this simple fact. There are regions of reality that exist, and yet will never enter our awareness. This is not because we lack intelligence, or technology, or imagination. It is because the universe itself places limits on connection. And that is the thing. Human knowledge has always grown by pushing boundaries, but the cosmic edge tells us that not all boundaries are meant to be crossed. Some are structural, some are built into space-time itself. The edge of the observable universe is a reminder that knowledge is not infinite, even in principle. There are truths that may remain forever beyond our reach. For a species that has long believed that enough effort could uncover everything, this realization can feel unsettling. We like to imagine the universe as a puzzle that can, given enough time, be fully solved. But the edge suggests something else. It suggests that the universe is not a closed book waiting to be read from cover to cover. It is an open text with missing pages, passages forever sealed, chapters we can infer but never read directly. And yet, there is something deeply human in continuing to ask anyway, to explore despite limits, to seek understanding even when completeness is impossible. The edge of the universe does not extinguish curiosity. It refines it. It teaches us humility without demanding surrender. We are reminded, too, of scale. The observable universe is vast beyond ordinary comprehension, and yet it may be only a fraction of what exists. Humanity occupies not just a small region of space, but a small region of reality. Our planet circles an ordinary star in an unremarkable galaxy, itself one among billions. And even that enormous setting may be just one patch of a much greater cosmic tapestry. This realization does not diminish us. It reframes us. Meaning does not come from size or centrality. It comes from awareness. The universe may be immense, indifferent, and largely inaccessible, but within one small corner of it, matter has arranged itself into beings capable of wonder. That fact alone is extraordinary. The edge of the universe reminds us that every observation we make is partial, every map incomplete, every theory provisional. We do not see the universe as it is. We see it as it was, filtered through time, limited by light. Even our most confident statements about reality are based on shadows of the past. We live, quite literally, surrounded by ancient light. This has implications for truth itself. Scientific truth is not absolute revelation. It is the best description possible within constraints. It is always open to revision, not because it is weak, but because it is honest. The edge of the universe embodies this philosophy. It is a physical manifestation of epistemological humility. There is also a quiet ethical lesson here. Recognizing our limited perspective can foster intellectual humility. It can soften certainty. It can remind us that our beliefs, however strongly held, are shaped by position, by access, by history. The universe does not revolve around our viewpoint. Others, elsewhere in space and time, would see a different slice of reality. And perhaps this realization resonates beyond cosmology. In human affairs, too, perspective matters. Context matters. Limits of knowledge shape understanding. The cosmic edge becomes a metaphor for all the edges we encounter, cultural, personal, intellectual. It reminds us that what we see is never the whole. The fact that all observation is limited by light is especially poignant. Light is both generous and restrictive. It allows us to see across billions of years, and yet it enforces an unbreakable horizon. We are guests in the universe, permitted to witness certain moments, denied others. The universe shows us enough to inspire awe, but not enough to satisfy every question. And this balance may be intentional in a sense, not by design, but by consequence. A universe that revealed everything at once would leave little room for curiosity. Mystery is not a flaw in reality. It is a feature. It keeps inquiry alive. It ensures that understanding remains a process rather than a destination. The edge of the universe also challenges the idea of final answers. We often seek closure, conclusions, ultimate explanations, but cosmology teaches us that each answer opens new questions. The more we learn, the clearer it becomes how much we do not know. The unknown does not shrink, it expands. This can feel frustrating, but it can also feel liberating. We are not racing toward a final truth that will end curiosity. We are participating in an ongoing conversation with the cosmos. Each generation extends the horizon slightly, not to eliminate mystery, but to deepen it. The edge reminds us that we live within a moment. The observable universe we see today is not the same as the one seen by observers in the distant past, nor will it be the same in the far future. Horizons shift, galaxies fade, light is lost. Our cosmic view is temporary. This lends our moment a fragile beauty. We exist at a time when the universe is still visible in rich detail, when ancient light still reaches us, when cosmic history can still be reconstructed. This will not always be so. Future observers may inherit a quieter sky, one in which much of the universe has slipped beyond view. In that sense, knowledge itself is time-sensitive. There are discoveries that can only be made during certain cosmic eras. We are beneficiaries of a particular alignment of time, expansion, and visibility. The edge of the universe reminds us that understanding is not just about intelligence, but about timing. There is also a deeper existential resonance here. The fact that we cannot know everything does not render life meaningless. On the contrary, it highlights the preciousness of what we can know. Meaning does not require total comprehension. It arises from engagement, from curiosity, from the act of seeking itself. The universe does not need us to understand it. And yet, we are here, asking questions, building instruments, telling stories about the cosmos. That activity is not demanded by physics. It emerges from consciousness, from the strange fact that the universe has produced minds capable of reflecting on its own limits. And perhaps this is the most astonishing thing of all. In a universe so vast that most of it may forever lie beyond awareness, a small part of it has become self-reflective. The edge of the universe exists, in part, because there are beings who care about edges. The recognition that we cannot know the whole does not negate the value of knowing the part. Our slice of reality, however small, is rich beyond measure. It contains complexity, beauty, history, and possibility. The universe does not ask us to comprehend it entirely. It offers us a window and invites us to look. The edge also tempers hubris. It reminds us that no matter how advanced our science becomes, there will always be horizons. This does not mean progress will stop. It means progress will change in character. Instead of chasing final answers, we may learn to live with open questions, to refine understanding rather than complete it. And perhaps, that is a more mature relationship with reality, one that values wonder alongside knowledge, one that accepts mystery not as defeat, but as context. As we stand within this vast, partially visible universe, the edge becomes a mirror. It reflects back our own nature as finite beings in an infinite or near infinite reality. It shows us our smallness, but also our capacity for awe. It reveals our limitations, but also our resilience. The edge of the universe does not diminish humanity. It situates us. It places us within a cosmos that is larger than our stories, yet generous enough to include us within them. And as this realization settles, another thought begins to form. If the edge teaches us about limits, perspective, and meaning, then there remain questions that science has not yet answered. Questions that linger precisely because of those limits. Questions about shape, destiny, causation, and future horizons. The edge of the universe does not conclude inquiry, it sharpens it. It leaves us with questions that remain open, inviting us to continue asking, not because answers are guaranteed, but because the act of asking is itself part of what it means to be human. And so we arrive at the questions that refuse to settle, the ones that remain standing even after all our careful reasoning, our observations, our equations, and our metaphors. These are the questions that linger at the edge of the universe like a quiet echo, unanswered not because we have failed, but because the universe itself has not yet, or may never, reveal them fully. One of the most persistent of these questions is deceptively simple. What shape does the universe have? We ask this because shape feels fundamental. We are creatures who live inside shapes, who navigate rooms, landscapes, horizons. We instinctively assume that the universe must have a geometry we could in principle understand, flat or curved, open or closed, finite or infinite. And yet, despite decades of observation and theory, this question remains open. We know that locally, space appears remarkably flat. Light travels in straight lines, angles behave as expected. On the largest scales we can observe, measurements suggest that the universe is very close to flat, but close is not exact. A tiny curvature could exist beyond our current ability to detect, and that tiny curvature, spread across an unimaginably vast cosmos, could fundamentally change the universe's global shape. If space curves back on itself, the universe could be finite without having an edge. Travel far enough in one direction and you might return to your starting point, not because you turned around, but because space itself loops. This idea challenges intuition, yet it arises naturally from general relativity, and still, we cannot confirm it. Our observable universe may be too small a sample to reveal the whole. Then there is the alternative, that the universe is truly infinite, not just practically, but actually infinite, extending without end in every direction. In such a universe, there is no global shape to measure, no boundary to map. Infinity resists containment. And if this is the case, then questions about the universe's size or edge may be fundamentally misguided. This leads naturally to another unresolved question. Why does the universe expand the way it does? We observe expansion. We measure its rate. We see that it accelerates. But the deeper reason remains elusive. Dark energy, the term we use to describe this acceleration, is not an explanation. It is a label. It captures behavior, not cause. Is dark energy a property of empty space itself? Is it a new field permeating the cosmos? Is it a sign that our understanding of gravity is incomplete on large scales? Each possibility has profound implications, and yet current observations cannot decisively distinguish between them. The universe expands as it does, and we describe it as best we can, but the why remains open. Closely tied to this is the question of what determines the limits of observation. Why does the observable universe have the size it does? Why is the cosmic horizon where it is? The answer involves the speed of light, the age of the universe, and the history of expansion. But this explanation feels incomplete. It tells us how the limit arises, not why the universe has these particular properties. Why is the speed of light what it is? Why did the universe begin when it did? Why does space-time have the structure that gives rise to horizons at all? These questions quickly push us beyond descriptive science into deeper theoretical territory. They remind us that some features of the universe may be contingent rather than necessary. Another unresolved question concerns the future of the cosmic edge. Will it change? Will the observable universe grow, shrink, or stabilize? Current evidence suggests that expansion will continue to accelerate, pushing more regions beyond our horizon. If this is correct, then the observable universe will become increasingly isolated over time. Galaxies will disappear. The cosmic background will fade. The universe will grow quieter. But this projection depends on assumptions about dark energy that may not hold forever. Dark energy could evolve. It could weaken. It could strengthen. It could even reverse. Each scenario leads to a radically different cosmic future, and without knowing the true nature of dark energy, we cannot know which future awaits. Then there is the question of whether the edge itself is changing in ways we do not yet understand. We know it shifts with time, but could it behave differently under extreme conditions? Could new physics alter horizons? Could quantum effects blur or redefine what we mean by an edge? At present, these questions remain speculative, but they highlight how much remains unknown. We also confront the question of initial conditions. Why did the universe begin in a state that allowed such vast structure to form? Why were the early density fluctuations just right? Too small, and galaxies would never have formed. Too large, and the universe would have collapsed into chaos. This apparent fine-tuning has inspired many explanations, none of which are universally accepted. Some see it as evidence for deeper physical principles yet to be discovered. Others invoke the multiverse, suggesting that many universes exist with different properties, and we inhabit one compatible with observers. Still others argue that the question itself may be ill-posed, that the universe simply is the way it is. And perhaps that last response is the most unsettling, because it suggests that some questions may have no deeper answer, that the universe does not owe us explanations that satisfy our desire for reason. This possibility forces us to confront the limits of explanatory ambition. Another open question concerns the role of time itself. We have seen how looking toward the edge of the universe is equivalent to looking into the deep past. But what is time, fundamentally? Is it a dimension like space, or something emergent? Did time begin with the universe, or did something exist before? Our current theories break down when we attempt to describe the earliest moments. The notion of before may lose meaning. Time may not extend indefinitely backward, or it may emerge from a deeper, timeless reality. We do not yet know. And without a theory that unites gravity and quantum mechanics, this question remains out of reach. There is also the question of causality. Horizons separate regions that can never influence each other. Does this fragment reality into separate causal domains? Is the universe fundamentally connected, or only locally so? Does causality itself have limits? From our perspective, the universe feels unified. But on the largest scales, it may be a patchwork of regions forever out of contact. If so, then the concept of a single, coherent universe becomes ambiguous. What we call the universe may be only one causal island among many. Then there is the question of observation itself. Why is the universe observable at all? Why is it transparent? Why did it cool in a way that allowed light to travel freely? These conditions were not guaranteed. They arose from specific physical processes early in cosmic history. Without them, the universe would be dark and inscrutable. This raises a deeper question about the relationship between observers and the universe. Is the universe structured in a way that makes observation possible by chance, or is there some deeper principle at work? This question sits uneasily between physics and philosophy. It has no clear answer, but it refuses to go away. Another unresolved issue is whether the laws of physics are truly universal. We assume that the same laws apply everywhere, even beyond our horizon. This assumption has served us well, but it remains an assumption. If other regions of the universe exist beyond our view, could their laws differ subtly or dramatically? We have no way to test this. Even within our observable universe, we encounter puzzles. Measurements of cosmic expansion made using different methods do not always agree perfectly. These tensions may hint at new physics or unknown systematic effects. Either way, they remind us that our picture of the universe is still incomplete. As these questions accumulate, it becomes clear that cosmology is not a finished story. It is a living inquiry. Each answer sharpens the questions that follow. Each discovery reveals new unknowns. The edge of the universe, far from being a conclusion, is a generator of curiosity. And perhaps, this is not a flaw. It is a feature. The universe is not a puzzle designed to be solved once and for all. It is a reality to be explored, interpreted, and reinterpreted. Our understanding evolves as the universe reveals itself gradually, selectively, and sometimes reluctantly. These unanswered questions also remind us that science progresses not by eliminating mystery, but by refining it. Early astronomers wondered what stars were. We now know they are suns, but that knowledge opened deeper questions about their formation, evolution, and death. In the same way, understanding the observable universe has opened questions about what lies beyond it. There is a quiet courage in admitting that we do not know, in acknowledging that some questions remain open not because we have not tried hard enough, but because the universe has not yet given us the tools to answer them. This humility does not weaken science. It strengthens it. The unresolved questions about the edge of the universe invite future generations to continue the search. New instruments may reveal subtle clues. New theories may reframe old problems. What seems unknowable today may become tractable tomorrow, or it may remain forever just beyond reach. And perhaps that uncertainty is precisely what keeps the story alive. A universe with no unanswered questions would be static, closed, finished. Our universe is anything but. It is dynamic, evolving, and generous with mystery. As we reflect on these open questions, we begin to see that the edge of the universe is not merely a scientific concept. It is a mirror of our own intellectual horizon. It shows us where our understanding currently ends and where imagination begins. And with that realization, we feel another shift coming. Because beyond the technical questions of shape, expansion, and causality lies something deeper. The edge of the universe does not only challenge our theories, it challenges our sense of meaning. It invites us to reflect on why we seek understanding at all, on how curiosity shapes identity, and on what it means to live in a universe that will always, no matter how far we go, remain partly unknown. And so, after tracing the edge of the universe through light and time, through uncertainty and imagination, we find that the edge begins to behave less like a boundary in space and more like a mirror held up to the human mind. The farther we push outward, the more clearly we begin to see ourselves reflected back. Not our faces, not our bodies, but our way of knowing, our way of questioning, our need to make sense of what surrounds us. The edge of the universe is not only a physical concept, it is a cognitive one. It emerges at the intersection between reality and perception, between what exists and what can be known. And perhaps that is why it feels so powerful. It exposes the structure of human understanding just as much as it exposes the structure of the cosmos. From the very beginning, humanity has defined itself by its horizons. Early humans lived within the edge of a valley, a forest, a shoreline. Beyond that edge lay danger, mystery, and possibility. As tools improved and courage grew, the edge moved outward. Mountains were crossed, oceans were sailed, maps expanded, and each time what lay beyond the edge reshaped how people understood the world and their place within it. The cosmic edge is a continuation of this story on the grandest possible scale. It is the latest horizon we have encountered, and like all horizons before it, it forces a reckoning. It asks us to confront how much of reality lies beyond direct experience, and how much of our understanding is built from inference, imagination, and trust in patterns. When we speak of the edge of the universe, we often speak in scientific terms: horizons, expansion, light cones, geometry. But beneath those technical ideas lies something deeply human, a desire to know where we are, a need to situate ourselves within the vastness. The edge becomes a reference point, even if it is not a physical place we can reach. And that is the thing. Humans are meaning-making creatures. We do not merely observe the universe. We interpret it. We tell stories about it. We embed ourselves within its narrative. The idea of an edge offers a powerful story. It gives shape to the unknown. It provides a sense of scale against which our own existence can be measured. Yet the universe resists being neatly framed. Each time we think we have reached the boundary, it dissolves into something subtler. The edge becomes a horizon, not a wall. A limit of vision, not a limit of existence. This repeated frustration is not accidental. It reveals something fundamental about the relationship between mind and cosmos. Our understanding grows not by eliminating mystery, but by relocating it. What was once mysterious becomes familiar, and new mysteries emerge beyond it. The edge of the universe marks the current boundary of that process. It is where explanation gives way to questions, where certainty fades into probability. And perhaps, this is not a flaw in human knowledge. It may be its defining feature. We are not designed to hold the entire universe in our minds. We are designed to explore, to approximate, to refine. Each generation inherits a set of questions, pushes the edge a little farther, and leaves new questions behind. In this sense, the edge of the universe is not static. It moves not only with cosmic expansion, but with human understanding. What was once unimaginable becomes commonplace. What was once speculative becomes measured, and what was once unaskable becomes the focus of entire fields of study. The history of science is a history of expanding edges. The edge of the visible sky gave way to the realization that stars are suns. The edge of our galaxy gave way to the discovery of countless other galaxies. The edge of classical physics gave way to relativity and quantum mechanics. Each expansion reshaped humanity's self-image. And yet, no matter how far the edge moves, it never disappears. There is always a beyond, always a question that cannot yet be answered. The universe seems structured in such a way that complete comprehension remains out of reach, and that persistent gap may be essential. If the universe were fully knowable, fully contained within a final theory, what would that mean for curiosity, for wonder, for the drive to explore? Mystery is not merely an obstacle to understanding, it is a catalyst for it. The edge keeps curiosity alive. The edge of the universe also challenges our sense of significance. In a cosmos that may be infinite or unimaginably vast, it is tempting to feel insignificant. A small species on a small planet, confined to a small region of space-time. And yet, significance does not arise from size. It arises from awareness. The universe does not reflect on itself everywhere. Most of it may be silent, unconscious, unfolding without commentary. But here, in one tiny corner, matter has become aware of the whole. The edge of the universe exists as a concept only because there are beings capable of conceiving it. That alone is remarkable. The fact that the universe contains within it entities that can ask where it ends, or whether it ends at all, that can trace its history, measure its expansion, and ponder its meaning. The edge of the universe is not just out there, it exists within human thought. And perhaps, I suppose, this gives the edge a dual nature. Physically, it is a horizon defined by light and time. Psychologically, it is a boundary defined by curiosity and imagination. Both are real. Both shape how we engage with reality. The mirror metaphor becomes especially powerful here. When we ask about the edge, we reveal our assumptions about reality. Do we expect it to have boundaries? Do we assume it must be finite? Do we believe that everything must be observable to be real? Each answer tells us as much about ourselves as about the universe. For centuries, humans believed the earth had an edge, not because it did, but because that belief fit their experience and intuition. When that edge vanished, it transformed not just geography, but philosophy. Humanity's conception of itself changed. The cosmic edge may play a similar role. If we come to accept that the universe has no edge in an absolute sense, that it may be unbounded or infinite, then our place within it must be reimagined, not as inhabitants of a bounded cosmos, but as participants in an open-ended reality. At the same time, accepting limits does not mean surrendering ambition. The edge of the observable universe may be fixed by physics, but the edge of understanding is not. We can deepen insight without expanding reach. We can refine theories, uncover patterns, and build coherence even within constraints. The universe does not ask us to know everything. It asks us to engage honestly with what we can know, to respect uncertainty, to distinguish between evidence and speculation, to remain open to revision. These are not just scientific virtues. They are human ones. And, there is something quietly ethical about this. Recognizing limits encourages humility. It tempers dogmatism. It reminds us that certainty is rare and perspective is partial. In a world often divided by absolute claims, the cosmic edge offers a lesson in restraint. The idea that each generation expands the edge of understanding is also deeply hopeful. It suggests continuity. That knowledge is not a static possession, but a relay. Each generation inherits questions, tools, and insights, and passes them on enriched but incomplete. The universe, in this view, becomes a long conversation across time. Early observers asked where the stars were. Later ones asked what they were made of. Today, we ask where the universe ends, and whether that question even makes sense. Future generations will ask questions we cannot yet imagine. The edge of the universe thus becomes a symbol of intellectual continuity. It marks where one era hands curiosity to the next. It is not a finish line. It is a handoff. And perhaps, the strangest thing is that despite knowing how limited we are, we continue to want to go farther, to look deeper, to ask more. This impulse seems built into us. It is not satisfied by answers alone. It is driven by the act of questioning itself. The universe, in turn, seems perfectly suited to this impulse. It reveals just enough to invite exploration, but not enough to end it. It offers patterns, but not finality, structure, but not closure. As the edge of the universe becomes a mirror of human cognition, we begin to see that the search for cosmic boundaries is also a search for meaning, not meaning imposed from outside, but meaning constructed through engagement, through curiosity, through reflection. The edge teaches us that understanding is relational. It arises between observer and observed, between mind and cosmos. Neither alone produces meaning. Meaning emerges in the interaction. And so, as we stand before this final conceptual horizon, we are not confronted with an ending, but with a reflection. The universe looks back at us through the idea of the edge and seems to say, this is how far you can see, and this is how far you have come. But it does not say stop. It remains open, vast, partly hidden, waiting not to be finished but to be explored again and again by minds that know they will never grasp it fully and yet cannot help but try. And with that recognition, the story does not close. It breathes, because the edge of the universe, like the edge of understanding, is not a conclusion. It is an invitation, quietly urging us to continue listening, continue wondering, and continue stepping, generation after generation, toward horizons that will always remain just beyond reach. And so, after all these reflections, after letting the edge of the universe become a mirror for thought, a horizon for knowledge, and a quiet reminder of our limits, the story does not end. In a curious way, it begins again, because what we have really been tracing all along is not a line in space, but a pattern in how understanding unfolds. The edge of the universe, you see, has taught us something subtle. It has shown us that reality is not arranged for completion. It does not offer a final frame, a last page, or a definitive boundary where curiosity can finally rest. Instead, it reveals itself in layers. Each layer feels complete until it is not. Each horizon feels like an ending until it turns out to be another beginning. This pattern repeats everywhere in science. The atom was once thought indivisible, a final unit of matter. Then it opened into electrons, nuclei, quarks, and deeper questions still. The Milky Way was once thought to be the whole universe, until it became one galaxy among countless others. Each time, what seemed like an edge dissolved under closer inspection, replaced by something vaster and more intricate. And that is the thing. The edge of the universe fits perfectly into this tradition of vanishing edges. It is not an anomaly. It is a continuation. The universe seems to invite us to approach boundaries, only to reveal that they are not walls but thresholds. They mark transitions in understanding rather than limits of existence. When we ask about the edge, we are engaging in a deeply human act. We are testing the scope of our concepts. We are probing whether our mental categories still apply. Does space behave the way we expect? Does time mean what we think it means? Does existence require observability? These are not purely scientific questions. They sit at the intersection of physics, philosophy, and lived experience. And perhaps, I suppose, that is why the idea of the edge resonates so strongly. It compresses many of our deepest concerns into a single image. Concern about limits, about knowledge, about meaning, about whether reality is ultimately accessible or forever partially hidden. The universe answers these concerns not with clarity, but with structure. It shows us that there are horizons imposed by light and time, that there are regions forever beyond causal contact, that there are questions we can frame but not test. Yet it also shows us something else, that within these constraints understanding is still possible, rich, detailed, transformative understanding. We can measure the age of the universe. We can reconstruct its early history. We can map its large-scale structure. We can predict its future behavior with remarkable accuracy. The fact that we cannot know everything does not trivialize what we can know. On the contrary, it highlights how extraordinary that knowledge is. The edge of the universe teaches us to distinguish between completeness and coherence. We may never have a complete picture of reality, but we can have a coherent one. We can build models that make sense of observations, that fit together, that explain patterns. Coherence, not totality, may be the true aim of understanding. This shift in perspective is important. It frees us from the expectation that science must eventually answer every conceivable question. Instead, science becomes a disciplined way of expanding coherence, of making sense of what can be connected, while acknowledging what cannot. And there is a quiet maturity in that stance. It recognizes that not all mysteries are problems to be solved. Some are contexts to be lived within. The edge of the universe may be one of those. It defines the stage on which inquiry takes place, rather than a riddle demanding resolution. As we reflect on this, we may notice that the edge also reframes our sense of progress. Progress is not a straight line toward final truth. It is a widening circle of insight, with new questions always forming at the perimeter. The edge moves not because reality changes, but because understanding grows. Each generation inherits an edge shaped by the discoveries of the past. Early humans inherited the edge of the horizon and the night sky. We have inherited the edge of the observable universe. Future generations may inherit edges shaped by concepts we cannot yet imagine. This inheritance is cumulative. Knowledge builds. Even if ultimate answers remain elusive, each step forward reshapes the questions themselves. The edge today is not the same as it was a century ago, and it will not be the same a century from now. The universe seems to reward this incremental approach. It does not reveal everything at once, but it does respond to careful inquiry. Subtle measurements reveal deep truths. Patient observation uncovers hidden structures. The cosmos is not opaque, it is selective. And perhaps, this selectivity is what makes the universe feel almost conversational. We ask a question, and it answers, but not always the one we expected. We think we are asking where the universe ends, and instead we learn how observation works. We think we are asking about boundaries, and instead we learn about time. We think we are asking about existence, and instead we learn about ourselves. The edge thus becomes a pedagogical tool. It teaches by resistance. By refusing to be reduced to a simple answer, it forces us to refine our thinking, to clarify assumptions, to separate what we know from what we guess. In this way, the edge of the universe is not a disappointment. It is an educator. It guides thought toward deeper structures. It discourages simplistic conclusions. It invites patience. There is also a sense in which the edge connects science back to its oldest roots. Early philosophy was concerned with limits, with the nature of being, with the relationship between appearance and reality. Modern cosmology, despite its advanced mathematics and instruments, returns us to these same questions, now informed by data and theory. The edge reminds us that science did not replace philosophy. It refined it. It gave it tools. It anchored it to observation. But the fundamental questions remain recognizable. What exists? What can be known? What lies beyond experience? And perhaps this continuity is reassuring. It tells us that human curiosity has a shape. It bends towards certain questions again and again. The edge of the universe is simply the latest expression of an ancient impulse. As we contemplate this, the universe begins to feel less like an object and more like a context, not something standing apart from us, but something we are embedded within. Our questions about its edge are also questions about our own boundaries as knowers. This embeddedness has consequences. It means that understanding is always situated. There is no view from nowhere. Every description is from somewhere, from some time, from some position within space-time. The edge of the universe makes this explicit. We cannot step outside the universe to see it whole. We cannot adopt a neutral vantage point beyond space and time. We are always inside the system we are describing, and that fact shapes every conclusion. Rather than undermining knowledge, this realization deepens it. It reminds us to include the observer in the account, to recognize that perspective is part of reality, not an obstacle to it. And perhaps, I suppose, this is one of the most profound lessons of modern cosmology. The universe is not just something we study. It is something we participate in. Our observations are events within it. Our theories are patterns within it. Our questions are phenomena it has produced. The edge of the universe, then, is not external to humanity. It is a feature of the relationship between humanity and the cosmos. It exists because we exist as beings who observe, measure, and wonder. As we continue to reflect, another thought quietly emerges. If the edge of the universe is not a final boundary, if it continually recedes as understanding grows, then perhaps the story we are telling is not about reaching an end at all. It is about learning how to live with openness. Openness to uncertainty. Openness to revision. Openness to the possibility that reality is richer than our current descriptions. The edge trains us in this openness. It also trains us in patience. Cosmic timescales dwarf human ones. Discoveries unfold slowly. The universe does not rush to be understood. It unfolds at its own pace, indifferent to our impatience. And yet, despite this indifference, it remains accessible enough to inspire awe. The fact that we can even frame questions about the edge of the universe is astonishing. It speaks to the deep compatibility between human cognition and cosmic structure. The universe may not be obligated to make sense to us, but it does, to a remarkable degree. Mathematics describes it, observation reveals it, reason connects its parts. The edge marks where this compatibility thins, but it does not vanish entirely. This thinning is important. It keeps humility alive. It prevents the illusion of final mastery. It reminds us that understanding is always provisional. As we stand here, at this conceptual threshold, we feel the pull of what comes next, because beyond reflection lies synthesis. Beyond questions lies the attempt to weave them into a larger narrative. The edge of the universe has shown us limits, mirrors, horizons, and meaning. It has prepared us for a final turn, not toward a conclusion, but toward a deeper appreciation of strangeness itself, toward the realization that the universe is not just large, but profoundly counterintuitive, that its deepest truths often run against expectation, that what seems strange at first glance may be the most accurate description of reality. And so the journey naturally continues, away from the edge as a boundary, and toward the edge as a symbol of how reality continually surprises us, inviting us to sit with wonder, to accept strangeness, and to recognize that the universe, in all its vastness, is still far stranger than we can imagine. And so we come gently to what feels like an ending, though the universe itself resists such a word. After traveling together through horizons of light and time, through uncertainty and expansion, through mirrors of perception and questions without answers, we find that the edge of the universe has quietly transformed before our eyes. It is no longer a distant idea at the farthest reach of space. It has become something intimate, something woven into the way we think, the way we wonder, the way we exist. The phrase stranger than you can imagine is not a dramatic flourish. It is a sober statement of fact. Again and again, the universe has revealed itself to be more subtle, more counterintuitive, more layered than the stories we first tell about it. We expected walls and found horizons. We expected distances and found time. We expected certainty and found probability. Each expectation gave way, not to chaos, but to a deeper kind of order that asks more of us than simple understanding. The edge of the universe is not a line drawn in the dark. It is a relationship between light and time, between expansion and causality, between observer and observed. And once we see it this way, we begin to understand that the universe does not simply exist out there, waiting to be catalogued. It unfolds in dialogue with those who observe it. This does not make reality subjective. The universe does not change its behavior based on our thoughts. Galaxies still form, space still expands, light still travels at its unyielding speed, but meaning emerges in the interaction. The edge gains significance because there are minds capable of noticing limits and asking what they imply, and that is the thing. The universe is vast beyond comprehension, and yet it has produced beings who feel compelled to comprehend it anyway. There is something quietly astonishing in that. On a small planet orbiting an ordinary star, within one galaxy among billions, matter has arranged itself into a form that can reflect on the whole. That alone may be one of the most extraordinary facts in all of cosmology. When we say the universe has an edge, we are really speaking about the limits of connection. Beyond a certain horizon, events can no longer influence us. Light emitted there will never arrive. Causes and effects are severed. This is not a philosophical limit, it is a physical one. And yet, the meaning we draw from that limit is deeply philosophical. We are used to thinking that what matters must be accessible, that reality must be observable to be real. But the edge of the universe gently dismantles that assumption. There may be vast regions of existence forever beyond our awareness. They may host galaxies, stars, perhaps even life. Or they may not. Either way, their existence does not depend on our ability to know them. This realization can feel unsettling, but it can also feel liberating. The universe is not constrained by our need for completeness. It is free to be larger, stranger, richer than our models. Our ignorance does not diminish reality. It simply defines the boundary of our participation. And perhaps, I suppose, that is a healthier way to think about knowledge. Not as conquest, not as total mastery, but as participation within limits. We learn what we can, where we can, when we can. We build coherence, not totality. We tell stories that fit the evidence, knowing they will one day be revised. The edge of the universe reminds us that science is not a ladder with a final rung. It is a horizon that recedes as we approach. Each discovery expands the field of the known, but also sharpens the outline of the unknown. Mystery does not shrink. It evolves. This is not a failure of science. It is its strength. A science that claimed final answers would be brittle, closed, dogmatic. A science that acknowledges limits remains flexible, curious, alive. The universe rewards this attitude. It reveals itself gradually, selectively, through careful listening rather than forceful demands. There is also something deeply temporal about the edge. We live at a particular moment in cosmic history, when the universe is old enough to host complex structures, yet young enough that much of it remains visible. This is not guaranteed. It is contingent. In the far future, observers may find themselves in a quieter cosmos, with fewer clues about the universe's origins. That means our time is special, not in a mystical sense, but in a historical one. We are beneficiaries of a cosmic window. Ancient light still reaches us. Distant galaxies still glow. The universe is still telling its story loudly enough for us to hear. And that places a kind of responsibility on us, not to rush to final answers, but to listen carefully, to preserve curiosity, to pass on not just knowledge, but questions. The edge of the universe is not something we will resolve once and for all. It is something we will continue to engage with, generation after generation. Each generation expands the edge of understanding a little farther. Early humans expanded it by naming the stars. Later ones expanded it by measuring their motions. We expanded it by discovering galaxies, expansion, horizons. Future generations will expand it in ways we cannot yet imagine. And perhaps that continuity is the most comforting thought of all. We are part of a long chain of inquiry. Our questions did not begin with us, and they will not end with us. The universe does not demand that we finish the story. It invites us to add a chapter. The edge of the universe also teaches us something about humility. It reminds us that certainty is rare on the largest scales, that confident statements must be tempered by awareness of perspective, that our position in space and time shapes what we can know. This humility is not weakness. It is clarity. It allows us to distinguish between evidence and speculation, between what is known and what is guessed, between wonder grounded in reality and wonder that drifts into fantasy. At the same time, the edge does not extinguish imagination. It sharpens it. The inability to observe beyond the horizon does not prevent us from thinking about what might lie there. It simply requires honesty about the status of those thoughts. Imagination becomes a tool, not a substitute for evidence. And there is something beautifully balanced about this. The universe invites both rigor and wonder. It allows mathematics and poetry to coexist. It can be described with equations, and yet those equations point toward realities that feel almost poetic in their strangeness. The universe is not just large. It is weird. Space expands. Time bends. Horizons form without walls. Regions disappear without moving. Light carries history. These are not intuitive ideas. They require us to stretch our minds, to let go of everyday metaphors. And when we do, something remarkable happens. Our sense of reality deepens. The world becomes less familiar but more meaningful. We realize that our everyday experience is just one thin slice of a much richer structure. The edge of the universe, then, is not something to fear. It is something to respect. It marks where our concepts need refinement, where our intuitions fail, where learning begins again. There is also a quiet emotional dimension to all of this. When we look at the night sky knowing what we now know, the stars are no longer just points of light. They are messengers from the past. Some carry news from billions of years ago. Some mark regions that may already be slipping beyond reach. The sky becomes a living archive, a record of what the universe once was, not what it is now. And that can evoke a sense of melancholy. We are always looking backward, always receiving delayed messages, always slightly out of sync with reality. But there is beauty in that too. The universe has memory, and we are able to read it. We can reconstruct events that happened long before Earth existed. We can trace the story of matter from simplicity to complexity. We can see how the conditions for life emerged. In this sense, the universe is generous. It does not hide its past entirely. It leaves clues. It allows reconstruction. It invites interpretation. The edge simply marks where that generosity ends, where light no longer arrives, where silence begins, and even that silence has meaning. It tells us something about the structure of space-time, about causality, about limits. And perhaps, this is where the idea of the edge becomes almost comforting. It tells us that not everything is available, that there are boundaries we cannot cross. In a world that often feels overwhelming in its demands, there is relief in recognizing that some things are not ours to know. We do not need to carry the whole universe in our minds. We only need to engage honestly with the part we can reach. That engagement is enough to produce awe, humility, and insight. The edge of the universe also reframes our sense of importance. We are not central. We are not privileged observers of a complete picture. but we are participants in a remarkable process. The process by which the universe becomes aware of itself in fragments. Each observation, each theory, each question is an event in the universe. Knowledge is not external to reality. It is part of it. The edge of the universe exists partly because there are minds who define edges, and that thought leads us gently to a final realization. The universe does not need to be fully understood to be meaningful. Meaning arises in the act of engagement, in curiosity, in wonder, in the willingness to ask questions that may never be fully answered. The edge of the universe is not a failure of understanding. It is a feature of a reality that is larger than any single perspective. It ensures that exploration never ends, that there is always more to learn, more to imagine, more to reflect upon. And so, as we stand here, having followed the idea of the edge from naive boundary to subtle horizon to mirror of cognition, we can let go of the need for closure. The universe does not offer it, and perhaps that is a gift. Instead of an ending, we are left with an invitation to keep looking, to keep questioning, to keep listening to the faint ancient light that reaches us across time, to accept that the universe will always be partly hidden, and to find beauty in that hiddenness. Because the strangest thing about the edge of the universe is not that it exists, or that it recedes, or that it may not exist at all. The strangest thing is that we care, that we ask, that we wonder. In a cosmos so vast that most of it may forever lie beyond awareness, there are beings who sit beneath a dark sky and ask where it ends. And perhaps that question, more than any answer, is what truly connects us to the universe. And so the story does not close. It remains open, like the universe itself, waiting for the next question, waiting for the next observer, waiting for the next moment when curiosity reaches out toward the dark and finds not a wall, but another horizon quietly shimmering just beyond reach.